Hello. 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 Hello.
Designed to equip our esteemed faculty with the knowledge to build a safer, more resilient future. We are honored to have a distinguished assembly of academic leaders and experts joining us virtually today. Let us dedicate this moment to seek peace and wisdom. As we begin this program, I request everyone to observe a moment of silent prayer. Okay, it is now time to extend a formal and a heartfelt welcome to all our dignitaries and participants. Ms. Anju EM, Head of the Department of Civil Engineering, IES College of Engineering, to deliver the welcome note and formally introduce our esteemed guests. Ma'am, please. A formal and a heartfelt welcome to all our dignitaries and participants.
Good evening, all.
Ms.
I
Anju
respected
EM,
Dr.
it is
Dr.
now
Ajiz
time to
Sir, Assistant Professor,
Head of the
NIT
Department of Civil
Calicut,
Engineering,
Mr.
IES
Said
College of
Mohammed PT Sir,
Engineering,
President,
to
IES
deliver the welcome
Education
note and
City,
formally introduce our
Dr. S. Prilly
esteemed
Sangeeta,
guests.
Principal, IES
Ma'am,
College of
please.
Engineering,
Head of the Department of
distinguished
Civil Engineering,
participants. from various institution and industry, ICT wing members, and my dear colleagues. It gives me immense pleasure to welcome you all this common platform where participants have joined us from various states. From today onwards, for the next 6 days, we will be together for the AICT training program, sponsored online faculty development program on disaster management and resilience infrastructure. On behalf of the Department of Civil Engineering, IES College of Engineering, I extend a warm and heartful welcome to Dr. S, Assistant Professor, NIT Calicut. Sir is a person vision and hardworking to achieve in that remarkable dedication and sincere effort. I would also like to extend warm welcome to Mr. Said Mohammed PT, sir, President IES Education City, whose constant support, keen observation, and thoughtful dedication making all decision making has been always strong pillar for our institution. A special and respectful welcome to Dr. S. Prilli Sangida ma'am, Principal, IES College of Engineering, the backbone of our institution, whose consistent focus on the academic excellence of students and the personal development of faculty members. Finally, I warmly welcome all the participants, ICT wing members, and my dear colleagues to this inaugural ceremony. I hope this FTP will be fruitful learning experience for every involved persons. Thank you.
Thank you, ma'am, for the warm introduction. We are immensely fortunate to have a visionary leader whose guidance consistently inspires excellence in teaching, research, and outreach. I now humbly invite our respected principal, Dr. S. Brilli Sangeeta, to grace us with the principal's address. Ma'am, please.
Am I audible?
Yes, ma'am.
Respected guests of the day, our president, management members, and esteemed resource persons, dear faculty members and participants of this FTP. A very warm welcome to one and all present here today. It is really a great pride and enthusiasm that I'm here today to join this faculty development program on disaster management and resilience infrastructure. This program represents a significant milestone in our commitment of academic excellence, and not only that, our responsibility towards building a safer, a more resilient society. The timing of this program could not be more pertinent. We live in an age where there is a lot of environmental challenges. Climate change is no longer a distant threat. It is a present reality that demands immediate and informed action. When we speak about infrastructure, it is that once seemed adequate is now vulnerable. And conventional, there are a lot of conventional approaches to construct, to plan, to get a better solution nowadays. I hope this 5-day faculty development program has been meticulously designed to address all the critical aspects of disaster management, the preparedness, and the resilience. This is all about the technical knowledge, giving a paradigm shift from the approach engineering and infrastructure development. So today I am really grateful to our distinguished resource persons who have graciously agreed to share their experiences with all of us to make us very comfortable to take through this 5 days FDP. Maybe you'll be getting a lot of insights from this 5 days FDP that may help you in research areas, that help you in making policy formulations and practical implementations in the field of disaster management. And I'm really confident that these insights will provide invaluable insights, valuable change in all of us. Now it's a time to extend my sincere appreciation to the organizing committee for their tireless efforts that made this program a good start. Hopefully, this 5 days you'll be feeling comfortable with all the sessions, and you'll be having a lot of takeaways from this session. Not only this, I appreciate all the participants who participated in this program. This is a pure opportunity for you all, and my best wishes for you all for a wonderful experience through this 5 days program. Thank you all for your presence and participation. Let us all together make the first step towards building a more resilient future. Thank you all.
Thank you, ma'am, for those insightful words. We now move on to the most pivotal segment of our ceremony. It is a profound honor to introduce our inaugural speaker for today, Dr. Ajish S.S., Assistant Professor, National Institute of Technology, Calicut. His expertise in the field of civil engineering and disaster resilience is highly commendable. We request Dr. Ajish S.S. to deliver the inaugural address and formally declare the online FDP on disaster management and resilient infrastructure open. Sir, please.
Uh, Good evening. Am I audible?
Yes,
Hello? Hello.
sir, audible, sir.
Yeah.
Yes, sir, audible.
Yeah. Please enable my video.
Yes,
I
sir.
cannot enable my video. It's disabled.
Okay, sir.
Yeah. Uh, I hope I am visible also, right?
Yes, sir.
Yeah. So good evening, one and all. Respected principal, head of the department, distinguished resource persons, esteemed faculty members, and dear participants. It gives me immense and great pleasure to welcome you all to this AICT Atal sponsored faculty development program on disaster management and resilient infrastructure, organized by the Department of Civil Engineering, IES College of Engineering. So this will be a 5-day FDP program, basically in online mode. So coming to the topic of this particular uh, online FDP, disaster management and resilient infrastructure. It's actually a wide topic where a lot of stakeholders are there, but being civil engineers, our role will come in both management as well as building a resilient infrastructure. So the topic of this FDP is highly relevant in this context of modern infrastructure, as Principal Ma'am has rightly pointed out. So disasters, daily we are seeing in news, landslides, earthquakes, fire, blast, lot of disasters we are hearing daily. So we need to have a proper management and we need to enable our structures to resist these sort of disasters. So the increasing frequency of both natural as well as man-made disasters across the globe highlights the urgent need for a resilient and sustainable infrastructure. So our main role is to build an infrastructure which is sustainable against disasters. As a civil engineers, educators and researchers, we have a vital role in developing the systems that can withstand disaster and ensure public safety. So considering all these aspects, this FDP is highly relevant. Over the next few days, this program will provide valuable insights into disaster risk assessment, mitigation strategies, resilient planning and design, and emerging practices through expert lectures and interactive sessions from academicians and industries. It aims to strengthen the academic understanding while linking theory with real-world application. So I will come into detail of my presentation during my turn. So since it's an inaugural speech, I'm restricting here. I appreciate the dedicated efforts of the committee members for organizing this event. Also, I sincerely thank the organizers of this FDP to give me an opportunity to be the speaker of one of the sessions. I encourage all the participants to actively engage in the sessions, ask your questions, maybe in the middle or at the end of the sessions, and make the best use of this opportunity for learning and professional growth. With these words, I once again welcome you all and wish the program every success. Thank you one and all, and I declare that this particular FDP is inaugurated. Thank you.
Thank you, sir, for an exceptionally informative and motivating inaugural address. Your insights have set a powerful foundation for the program. The success of any interviewer hinges on the unwavering support of the management. We are delighted to have our esteemed management delegates with us today. Now, I invite Mr. Said Mohammed PT, President of Ideal Education Society, to deliver the presidential address. Sir, please.
Good evening, all. It's a matter of great honor and privilege to preside this FTP on disaster management and resilient infrastructure, supported by AICTE. At a time when the frequency and intensity of natural and human-made disasters are increasing across the world, such academic initiatives are not only relevant but urgent necessity. Recent natural calamities and industrial accidents have reminded us that disasters are no longer confined to distant geographies. They are realities and affect our economics and our people. Effective disaster management now demands an integrated approach that brings together engineering, governance, and community participation. In this context, the focus on resilient infrastructure is crucial. Infrastructure is not just about roads and buildings. It is the backbone of social and economic life. When the infrastructure is designed, built, and managed with resilience in mind, it can withstand shocks, recover quickly, and continue to serve society even under extreme conditions. Now, let us look into the role of academia and faculty. Faculty members and institutions play a pivotal role in this transformation. Through curriculum, research, and activities, teachers can shape a new generation of engineers and professionals who understand risk, value of sustainability, and can design systems that are robust, adaptable, and safe. This FTP provides a valuable platform to update knowledge and discuss innovative solutions with experts in the field. ICT's support for such program reflects a strong national commitment to quality technical education and capacity building. By engaging in this FTP, participants are contributing to a larger vision of safer and more resilient India. The, the learnings you gain here will eventually translate into better teaching and better policies on the ground. Over the coming days, this program will equip you with insights into risk assessment, disaster preparedness, emergency response, and resilient design principles. The true success of the FDP will lie in how these insights are carried back to classrooms, laboratories, and field projects. Let this FT be a starting point for continuous collaboration among institutions, government, agencies, and industry in building resilience at every level. With that hope and with a deep appreciation for the organizers, experts, and participants, and wish you all a fruitful and enriching learning experience. Thank you. Thank you all.
Thank you, sir, for such a motivating presidential address. To elaborate on the significance of modules and expected impact of this faculty development program, I now request Ms. Asha Devasikuti, Assistant Professor, Department of Civil Engineering, IS College of Engineering, to present a brief overview of the FDP. Miss, please.
Sorry for the delay.
Respected presidents, distinguished resource persons, respected principal, faculty members, research scholars, and dear participants. It gives me immense pleasure to welcome you all to the AACT Atal sponsored faculty development program on disaster management and resilient infrastructure, organized by the Department of Civil Engineering, IS College of Engineering, Chitale, conducted from 15th to 20th December in online mode. In the present scenario, the increasing frequency of natural disaster highlights the urgent need for the resilient infrastructure and sustainable engineering solutions. As educators and research scholars, it is our responsibility to stay updated with emerging technologies, innovative materials, and interdisciplinary approaches that enhance disaster preparedness and mitigation. This FTP has received an overwhelming response with 326 registrations, and we are pleased to accept all registered participants. The program includes 9 eminent resource persons, and also we have it is from both academic and industrial backgrounds, representing national and international institutions, and will cover 11 important and contemporary topics relevant to disaster management and resilient infrastructure. These sessions are scheduled to begin daily at 6 p.m. and on the final day, 20th December, the session will start at 2 p.m. I would like to inform all participants that as per AACT adult guidelines, full participation are mandatory to receive the completion certificate. A 30-minute assessment will be conducted on the last day, 20th December, and the attendance assessment is mandatory, and you should be logging with your own ID or with name. Participants who secure 70% or more marks in the assessment will be issued certificate of completion. Submission of the feedback form at the end of the FTP is compulsory. Participants are requested to log in at least 5 minutes before the commencement of each session. Active interaction and cooperation from all participants are highly appreciated for the smooth conduction of our FTP. I'm confident that this program will serve as an excellent platform for knowledge sharing, personal development, and academic collaborations among the faculty members and research scholars. Once again, I warmly welcome you all and wish this FTP great success. Thank you all.
To express our sincere gratitude to all the dignitaries and participants, I invite Ms. Steffi Maria Simon, Assistant Professor, Department of Civil Engineering, IES College of Engineering, to propose the vote of thanks. Ms. Please.
Good afternoon, everyone. It is with immense pleasure that I deliver this vote of thanks as we successfully concluding the ceremony of our online faculty development program on disaster management and resilient infrastructure. First and foremost, our deepest gratitude goes to our esteemed chief guest, Dr. Ajish S.S., Assistant Professor, NIT Calicut, for gracing this event and delivering such an inspiring words. Your words have truly set an ambitious and exciting tone for the week ahead. Thank you, sir, for sharing your invaluable time and vision with us. We are equally thankful to our president of IS Education Society, Mr. Saif Muhammad Sufi, for his continued guidance and unwavering support in making this crucial program a reality. Your commitment to faculty excellence is our greatest motivation. We are profoundly grateful to our principal, IS College of Engineering, Dr. S. Brilli Sangeeta, for her constant encouragement and belief in the professional growth of our faculty. I must also extend our sincere thanks to Ms. Anju EM, the head of the Civil Engineering Department, for her warm and gracious welcome, which beautifully set the stage for today's ceremony. A special word of thanks also goes to Ms. Asha Devasikuti, the Assistant Professor of Civil Engineering Department, for giving a brief note about this FDP. Finally, a hearty thanks to all the distinguished participants and faculty members who have joined us today. Your enthusiasm and presence are what truly bring this program to life. We look forward to a week of fruitful learning and meaningful collaboration. Thank you all once again.
Thank you, ma'am. Now, I request everyone to turn on your camera to have a photo session of the inauguration ceremony. Please. Participants, please turn on your cameras to have a photo session of the inauguration ceremony. So, this brings us to the conclusion of our inaugural ceremony. We thank all our esteemed guests for their valuable time and profound contributions. Dear participants, the first technical session will commence shortly at 6:40 p.m. Please stay connected. We wish you a highly enriching and productive faculty development program. Thank you all.
Thank you, ma'am.
A warm welcome to the first session of our faculty development program on fire resistant design and retrofitting. We have Dr. Ajish S.S. He is currently an assistant professor in the Department of Civil Engineering, NIT Calicut. He obtained his PhD from IIT Madras, M.Tech from the College of Engineering Trivandrum, B.Tech degree from the TKM College of Engineering Kollam. He has 2 years of industrial experience and 8 years of teaching and research experience. His primary research interests are computational structural stability, fire, and impact behavior of steel. Mainly focused on the development of a computational framework for the constraint buckling analysis of thin-walled steel sections. He has published articles in reputed international journals and conferences. He is the primary contributor for the development of the computational software Twilight IITM, a computational utility for calculating the elastic buckling stresses of thin-walled steel sections. Let's give him a warm welcome. Welcome, sir.
Thank you. Good evening, everyone. Am I audible, madam?
Yes, sir.
Yeah. So I will share my PPT first. So is my screen visible now?
Yes, sir.
Right. Thank you. So, good evening, all the participants. Myself, Dr. Rajesh, Assistant Professor, Department of Civil Engineering, NIT Calicut. So, this FDP is basically on the disaster resilient and sustainable infrastructure. So, if you see disaster, there are a lot of aspects. It's a wide topic where we have a lot of disasters which we need to address. So, I will be addressing a particular disaster known as fire. So, we are all familiar what is meant by a fire disaster. So, in news, we are seeing such sort of disasters where fire is emerging out somewhere and fire engines coming, so some casualties, all these aspects we are seeing. So we are mostly seeing the fire incidents on concrete structures. So basically all our structures are made of concrete. Residential buildings, if you see, the most possible place where the fire can occur. So that's made of concrete. But nowadays, if you see construction industry, more and more structures are being built using steel structures. So steel structures means it's not the big steel section which we are expecting. So it's about very lightweight steel structure. So we can build houses using very lightweight steel structure in quick time. So we can build a house in a progressing throughout the world. So in European countries, if you see, olden days they were using wooden structures. So now they have shifted from wooden structures to thin-walled steel structures. But one of the major aspect which the wooden structures as well as this thin-walled steel structures, the main concern is its resistance to fire. So if there is a fire incident, we all know wood is highly and it will soon catch fire and it will get destroyed. Everything will get destroyed. But if you see steel, we may expect that it is having some resistance to fire. So we will see how much the steel can resist fire, how much temperature it can withstand, how much is the reduction in its strength, what are the strengths which are going to get reduced. All these aspects will be covered in this particular lecture known as fire resistance of steel structures. Now, coming to the contents of this presentation. So first I will just briefly go into the classification and properties of structural steel. Then classification of fire. What are the various types of fire and what are the various repair strategies and fire protection strategies? These are the two common strategies. So if there is a fire accident, we need to reuse the buildings. For that, we need to have a suitable repair strategy. Moreover, we need to have fire protection strategy. So how we can protect our buildings from fire. So that is the next aspect. Then effect of fire on steel structures and design specifications considering these effects. So how the fire will affect the structure, how the strength will get affected. All these aspects will be covered. Then finally, the analysis techniques. So I will briefly go into the various analysis techniques. This is mostly a research topic. So how we can analyze the structure, steel structure subjected to fire. There are two types of analysis. All those details I will quickly cover. So before starting my presentation, my sincere acknowledgement to all my teachers who taught me, my PhD research guide, and some of his slides has been used here. His name is Dr. Arul Jayachandran, Professor, IIT Madras, and some of the internet resources.
Sir, please put in the slideshow.
It's in slideshow.
But we are seeing the two slides.
One second. Let me just. I mean, the next slide you are seeing, right?
Yes, sir.
Okay, one second. Let me clear it. So once again, I will share it. Is it all right now?
No, sir.
Okay.
In display settings, it will be there, sir.
Okay. Oh, the next slide is also visible, right?
Yes,
Yeah.
sir.
Oh, 1 minute. Is it fine now? Still there is an issue, or is it fine now?
No, sir.
No, sir.
Okay. So you are seeing two slides, or what is the issue actually?
Yes, sir. Next slide also it is coming there.
Oh, okay.
Or you can continue as it is, sir. No issue.
No, I will just make it. One second, I will just share it once again. Is it okay
Okay,
now?
sir.
Yeah.
Yes, sir. Okay.
Okay, right.
Thank you, sir.
Okay, fine. Sorry for the interruption. So these are my acknowledgements and the contents of this presentation. So now coming to steel. So what do you mean by steel? We are all familiar with what is steel. Steel is actually an alloy of iron and carbon. So olden days we have iron structures, and once the technology advances, we got steel structures where we will add slight amount of carbon to iron. So once you add carbon to iron, what will happen? So basically that will improve the strength and hardness. It will reduce the ductility and weldability and decreases the temperature resistance. So that is our main point. So if you add carbon to iron, it will decrease the temperature resistance. That is one major problem which we are facing. So when you see carbon steel, which is our modern steel, means maximum we will add up to 1.7% of carbon. We will have 1.65 or near to that, some quantity of manganese, silicon, and copper in it. So we can classify basically the steel into low carbon steel, mild carbon, medium carbon, and high carbon steel. So if the content of carbon is very less than 0.15%, we will call it as low carbon steel. Then 0.15 to 0.29 mild carbon, medium carbon 0.3 to 0.59, and we can have very high carbon steel also. Now, so alloy steel, so it's not only the carbon which we are adding. So there are a lot of additives which are being added to iron so that some of its properties are getting improved. So generally these additives will be less than 5% of the total quantity of the iron. So it will improve its strength. So our basic idea is to improve the strength of the steel, and sometimes it will reduce the ductility. So ductility is one of the major factor when we come to earthquake resistant design and all. So this, if you add more and more carbon, so the ductility of the steel will get reduced. So if you see modern day steel structures, so there are various types of specialty steels which will offer very high strength. So even in China, they are producing steels of grade 600 MPa and all. And some of the special characteristics of steel, specialty steel are corrosion resistant steel. Say, for example, the stainless steel, where we will add chromium to steel and it will offer the corrosion resistance. And we can have the fire resistant steel also. So corrosion resistance, weldability, fire fatigue behavior, these are all some of the properties which we need to address steel as a material. So the fire and fatigue, these are the two properties where the two phenomenon where the property of the steel plays a major role. So now when you see steel, how it has evolved out to the modern day steel. So olden days we have been using cast iron, so iron. So by heating iron ore in charcoal fire, we will, and by adding very high carbon content, like 2 to 4%. So we obtain the material known as cast iron. So the main disadvantage is it is very weak in tension. As we already know, how steel is advantageous over concrete. Steel has more tensile resistance capacity than concrete. So now coming to cast iron, it is very weak in tension. And so generally, but the advantage is it will not issue of steel structures, but cast iron will not rust. So this is one very old structure which is made of cast iron. So that is just to show you. So now then as period progressed, we have seen wrought iron where the addition of limestone into iron. So the carbon content will be very low, 0.15%, and it has some good tensile capacity. So you might have seen chains and crane hooks, which has been fabricated using this wrought iron. So, but disadvantage is it will rust. Then modern day steel. So coming from cast iron, wrought iron, and now we are moving towards the modern steel, the steel which is available nowadays. So this particular steel has been manufactured using a process known as Bessemer process. So where we have calibrated the carbon content such that the steel will have the best tension and compression capacity. So if you keep your carbon content between 0.15 to 0.25%, the steel will offer best tension and compression capacity. And all the modern day constructions are made of this this type of steel only. So, but the disadvantage is it will undergo rusting. Okay. So now the steel which I am going to talk is not the reinforcement which we are using inside concrete. So I am talking about steel sections. So if you see this picture, it's a picture of a bridge in Missouri. So you can see a lot of sections. So you might be familiar with I section, channel section, angle section. So I'm going to talk about all these sections, steel sections. So same like a concrete beam, we can have a steel beam, which will be fabricated using an I or channel shape. So how these structures are getting affected when it is exposed to fire. So now when you see steel as a construction material, so it has high strength to weight ratio. So major advantage over concrete structure is it is a homogeneous material. It has a fixed elasticity and it has a fixed strength and properties will be same in all the directions. That is one of the major advantage of steel over concrete, and high strength both in tension and compression. That is another advantage. And it will be ductile. Ductility means it has its own elongation capacity. So it will elongate larger, so that that particular property is known as ductility. And recyclability. So that is one of the major aspects of steel structure. So if you are building a house using steel structure, the life of the structure may be 50 years. So after 50 years, if you want to demolish the house, you can sell the steel. So you will get the value of that steel, scrap value of the steel. So it is unlike concrete, you will get some money back. So the another major advantage is its speed of construction. So if you see concrete structure, the time for construction will be much larger. So you need curing period, setting time, all these aspects will come into picture. But when you see steel structure, the speed of construction will be much faster compared to concrete structure. And good life cycle cost. That is what I told you, the demolition cost, how it will be. Maintenance cost, of course, it will be slightly higher than concrete. Initial cost also will be slightly higher than concrete. So major disadvantage is it requires skilled manpower. You might have seen a picture of a man which is doing the connection. So he is bolting a beam to a column. So an person expertise in bolting, welding, all these aspects are required for the steel construction. Now, coming to the mechanical properties. So we know tension and compression. So concrete is good in compression, steel is good in tension. So when you see the stress strain curve, so you might have already seen, everybody will be familiar about the tension curve of steel where we will be testing the bar. So if you want to test a steel section, so for example, an I section, what I will do, I will just cut a small piece of steel from that particular section. So we will call it as a test coupon. And I will put it in an UTM, apply tensile force, calculate the stress strain curve, and plot the stress strain curve. So in this figure, you can see two graphs. One is corresponding to mild steel and the other one is corresponding to high strength steel. So the initial slope will give you the elasticity, and you have an yield stress and you have an ultimate stress. So one is a low strength steel, the other curve is for a high strength steel. So all these are same like what you have seen in the reinforcement bars. So you have an yield stress, so then you have an ultimate stress, there is a strain hardening point. All these are common to the reinforcement bars as well as the steel sections which we are using. So major characteristics are the yield strength, ultimate strength, Young's modulus of elasticity. It will be generally of 200 gigapascal, and its elongation capacity. Elongation capacity means it is basically related to the ductility of the steel. So if you see a low strength steel here, it is having more elongation. The strain is more compared to a high strength steel. So for a high strength steel, the elongation will be much lesser. So if you add more carbon, your strength will increase, but your ductility will reduce. So that is how the carbon content plays a role in the steel structure. So now this is just an elaboration of what we have seen in the previous slide, stress strain curve of mild steel. So mild steel means its yield strength will be generally 250 megapascal. So yield strength means the point where the steel starts elongating without any increase in the stress. So we can see this particular point will be its yield strength. So again, we have an ultimate point where you will get the maximum stress of the material. We will call it as FU. So Fy is 250 means Fu will be generally 400 or 450. So that is how the material behavior will be. And then you have a strain hardening phase, and finally at around 0.23% strain, the steel will break. So that will be the property of steel. So its yield stress will be one property, ultimate stress. Then you have a breaking point, and we have the initial slope, which is nothing but the modulus of elasticity of the steel. Now coming to high strength steel. So compared to mild steel, you will not get a definite yield point. So you can see when you test the steel specimen, the curve will be something like a parabola. So it's not a parabola, it's a continuous curve. There is no sharp point. So one point where the strain corresponding to that is 0.2%. So if you draw a straight line from 0.2% strain, it will meet the curve at this particular point. That particular point will be taken as yield stress. And finally, the maximum stress will be the ultimate stress. So if you take Fu by Fy ratio, that will be much smaller than what we have seen in the case of mild steel. But of course, this Fy will be having a higher value. So high strength steel means it is having smaller elongation, and mild steel will be having larger elongation. Elongation in the sense it's the ductility. So that is what the property of the steel says. Now, types of steel sections. So this is the steel sections which we are talking mainly. Hot rolled steel. So how this steel is manufactured. So at around 2500 degrees Celsius, the steel is molten. In a molten state, it will be rolled through several rollers, and you will be getting such sort of shapes like eye, channel, angle, etc. So again, solid circular sections. So these are some sort of steel structures, sections which have been used in the olden days. Nowadays, these solid circular sections are not much being used for residential application or basic construction applications. So then we can have tubular sections. So this type of sections are quite common nowadays, and light gauge steel sections. This is one section which is now currently being used for a lot of low rise structures. So if the load carrying capacity, if the load acting on the structure is much lower, we will go for light gauge steel section. What is meant by light gauge? The thickness of the section will be very low. So say for example, its thickness will be of the range 1 mm to 3 mm maximum. So how these steel sections, light gauge steel sections are manufactured? You don't need to have a very high temperature for manufacturing light gauge steel sections. So you can just fold by using some mechanical operation, press breaking, folding, like that. So many operations are there. So if you take a steel plate and if you use some mechanical operations manually at room temperature, we can form it into a different shapes like channel, angle. So with stiffeners, all these types of sections are now quite popular in construction industry, especially for low rise structures. So if you see olden day construction, this steel is basically used for bridges. And if you see all the railway structures, if you go to a railway station or the railway platform, railway bridges, all these are steel structures. And those type of steel structures are basically hot rolled steel sections. So only in the railway or heavy load applications, we have been using steel sections. Nowadays, as the technology advances, we are using the steel sections in housing industry for a residential application especially. So mass production, so low cost construction, all these aspects. For all these aspects, we will be focusing on light gauge steel sections. So why I am emphasizing light gauge steel sections here is when there is a fire attack, these light gauge steel sections are more susceptible to failure than a hot rolled steel section. So that is why our topic will be more emphasized towards light gauge steel sections where the effect of fire will be quite significant. So now, we will just quickly go through the IS 800 classification. So if you are learning about steel, the Indian Standard Code of Practice is IS 800, which classifies steel into four major categories like plastic, compact, semi-compact, and slender. So IS 800 deals with hot rolled steel sections, which will come in either plastic, compact, or semi-compact. But there is another classification which is given in IS 800 known as slender steel sections. So these sections are basically our thin walled steel sections. So if you are using IS 800 for design, there is nothing to worry. Your section will be either plastic, compact, or semi-compact. But we are talking about the steel sections which are much lighter than the sections available in IS 800. So these sections are known as cold formed steel sections or thin walled steel sections. So the design guideline is based on IS 801, design of cold formed steel section. So that is how we can basically classify steel into two categories, cold formed as well as hot rolled steel sections. So now, how can we distinguish hot rolled and light gauge? So this is the table which is provided in IS 800 2007. So where the section, so if you see the geometry, if you get an I section or a channel section, just by comparing its width to thickness ratio, you will get some value. You will get some value where, yeah. You will get some value like plastic, compact, semi-compact, etc. So these are all coming under hot rolled steel classification. So if you have a section which is having value greater than this value, that means that section is a cylinder cross section. That is how we will identify whether the section is plastic, compact, semi-compact, or slender section. So these are the common hot rolled steel sections which are provided in IS 800. So cold formed means we can roll it into any shape. So if you see, this is just a brief outline of what is given in IS 800. So if you see, the plastics, compact and semi-compact sections are available in IS 800, where most of our sections are plastic. So some of them will be compact and a very few is semi-compact. So now we are coming into our main topic of interest, where the fire is attacking a steel structure. So fire attack on steel structure. This is one picture where which is taken after a fire incident. So you can see all these members have deformed, its shape is gone. So what will I do? Whether I should replace this material and provide with a new material, or what else I can do with this? So all these things we will see quickly, how we can deal with a fire affected structure. So if the building or a structure undergoes fire attack, the temperature of the elements combining the structure will be subjected to extensive heating and experiences high temperature. So all the steel sections which is subjected to fire will be subjected to high temperature. So unlike concrete, the fire resistance capacity of steel is much lesser. That is the point which we need to understand. So if a concrete building is subjected to fire, what will happen is all the things which are combustible will be burnt. So the cloths, the electrical appliances, all will catch fire. And finally, we will get sufficient time to extinguish the fire so that the concrete structure will get unaffected. But that is not the case of steel structure. So if it is subjected to fire, directly along with the electrical appliances, cloth, etc., the steel structure also will be subjected to the fire, and the temperature will have an effect on the strength of steel structure. So in practical cases, the fire catches the whole member within minutes, and the spread might not be uniform unless the fire catches the member equally from all the sides. So we don't know how the fire is actually attacking the structure. Sometimes it will start from one side, or sometimes uniformly from all the sides. So we have different scenarios where the fire attack can be detrimental. So our major concern in the design is how much time we will get. So suppose there is a fire accident in a building. So how much time we will get to extinguish the fire, or how much time we will need to evacuate all the people. So that period we need to have a grace period so that the people can be evacuated. Same like the earthquake design phenomena, fire also we will follow the same concept. So fire safety of steel buildings have received greater attention in recent times due to the increased usage of CFS members in residential, commercial, and industrial buildings. That is very important. CFS means cold formed steel. That means a steel section which is very much thinner than your conventional steel section. So this is widely being used in residential, commercial, and industrial buildings. Industrial buildings, again, a place where there is high susceptibility for a fire accident. So when we have these type of structures, we need to put great care in order to resist from the fire attack. Now, what are the various types of steel structures which are susceptible to fire? The first and foremost, the factory buildings. So warehouses. So if you see, if you want a very large open space, and if you have need a much higher roof, so we need to go for a steel structure. So you might be familiar with warehouses, factories, etc. Most of the factories will be having a steel roof, and the entire structure will be steel. This is a typical example. So in those places, the chances of fire accident will be much higher due to short circuiting or due to the usage of fire inside the factory. All these aspects are causing these buildings highly susceptible to fire accident. So then steel residential building. This is where nowadays the technology is moving forward, where we will be constructing the houses entirely using steel, like the floor, the columns, beams, everything will be steel, and the partitions will be provided with some lightweight materials. So that is one major area. Again, the cold form steel residential structures. So the second figure is a 3-story building, 3 or 4-story building, and the second one is the last one is a typical house we can fabricate using cold form steel. So the advantage of this structure is actually the speed of construction. We can quickly erect this particular structure in no time. So that is one major advantage of these type of residential structures. So all these are susceptible to fire accident. Now, what will happen when a steel structure is exposed to fire? So these are some of the figures, how this structure will get affected. So the entire thing will catch fire. So basically, when steel is subjected to very high temperature, its mechanical properties will get degraded. So what are the mechanical properties that will be affected by the fire is modulus of elasticity and yield strength. So we have already seen what is meant by modulus of elasticity and yield strength of steel. So that will reduce drastically as the temperature increases. And also the stress strain behavior. So we have seen two stress strain behaviors, one for mild steel, other one for high strength steel. But as all these are applicable at 20 degrees Celsius room temperature. But once the temperature increases to 300, 400 degrees Celsius, all these properties will be drastically affected. So all these strengths will get reduced. Now, how we can do the analysis of a steel structure? How can we study about the modulus of elasticity or yield strength? How the yield strength will get affected when there is a temperature? There are basically two methods. One is steady state method, another one is a transient state method. So towards the second half of this lecture, I will talk much about what is meant by steady state method and what is meant by transient state method. So just for the time being, we will just know these are the two methods for the analysis of steel structures which are subjected to fire. Now, among these two methods, the transient analysis will be more realistic and it will be simulating the real life conditions. And how we will design the structure for fire load. So you might be familiar with dead load, live load, then wind load, earthquake load, but there is something known as fire load. So if you want to design a structure to resist fire, so we need to first assess what will be the fire load acting on the structure and assess the effect of fire load on the structure and determine whether the steel frame can safely resist the load and ensure the overall integrity of the structure. It's same like the normal structural analysis which we are doing for the RCC buildings, where we will be assessing the effect of wind, earthquake, etc., etc. Similarly, there is something known as fire load and how it is affecting the steel structures. So this is one form of where we can express the fire load in various structures. So dead load, live load, you know what will be the weight of the structure. Based on that, we will fix the dead load, and based on the occupancy, we will fix the live load of building. So that will be expressed in kilonewton per meter square. But if you see fire load, we will have a unit known as kg wood per meter square. So what is meant by kg wood per meter square? If you, for a school building, if you put 15 kg of wood in a meter square area, how much fire it will generate? So that will, for that particular fire, we will design the school building to resist fire. So this is one way of representing. There are many other ways. So instead of wood, there will be some other materials which will be considered for expressing the fire load. So similarly for hospital, school building, hotel, office, departmental store, all these buildings are having different types of fire load. And you can see here a textile mill showroom. If you are designing a textile mill showroom for fire load, the fire load should be greater than 200, because we already know if there is a small fire in a textile building, it will spread as quickly as possible because the cloth materials are highly prone to fire. Okay, so similarly, we can have various types of fire load. There are some design standards available in Eurocode also specifying the uh, fire load. Yeah. Organizers, please mute the mic.
നിങ്ങളുടെ പ്രധാനപ്പെട്ട വാർത്തയുടെ വിശദാംശങ്ങളിലേക്കാണ്. കേന്ദ്രീകൃത ഗൂഢാലോചനയെന്ന് NIA കുറ്റപത്രം. പാക് ഭീകരൻ സാജിദ് ജാട്ട് മുഖ്യ സൂത്രധാരൻ. മത അടിസ്ഥാനത്തിലുള്ള കൊലപാതകമാണ് ഭീകരൻ ഉന്നമിട്ടതെന്നും NIA കുറ്റപത്രത്തിൽ വ്യക്തമാക്കുന്നു. ലഷ്കറും GRF അടക്കം കേസിൽ 6 പ്രതികളാണ്.
Organizers, please mute the yeah. Coming back, typical fire loads and its effect on steel under fire. So when you see fire load and fire. So the most important parameter when there is a fire incident is time. So when we will call that as fire resistance period. So whenever there is a fire accident, you should have sufficient fire resistance period so that we can evacuate the building and we can use our fire extinguishers. For all these aspects, we need to have adequate fire resistance period. So this graph will give you a gist of that, what is meant by a fire resistance period. So if there is a fire which is acting on a structure, if the steel is unprotected, we can see the dotted line. So the temperature keeps on increasing quickly, and about 30 minutes time, you will get around 750 degrees Celsius temperature, and it will quickly increase. And it is something similar to a furnace temperature. So if you keep something in an oven and heat it up, how that temperature is increasing. So quickly the temperature increases and the material will get heated up. So if the steel is unprotected, if you are not using suitable protective measures for steel, the furnace temperature, it will be much closer to the furnace temperature, where the temperature of the steel will be quickly increased. So our main strategy will be using some fire protection, so that we cannot avoid the increase in temperature, but we will get adequate amount of time. So we can see from this graph clearly, for a fire protected structure, in 90 minutes, the temperature have rise to 500 degrees Celsius. So we cannot avoid a fire accident. Definitely temperature will increase, but we will get adequate time to act. So that is our strategy when you are designing for fire. So we will be having maximum fire resistance period in order to protect the structure from fire, and that time we can use the fire engines or other adequate extinguishing methods. Now, what are the various types of fire? Quickly we will go through. Open fire. So it will be throughout the building. So when a building is subjected to open fire, each and every corner will be subjected to fire. And compartmental fire. So this is nowadays common in multi-storied houses. You can see the 10th story of the building, somebody's house will be having a short circuit. So only that building will get fire, and all other parts of the building will get unaffected. So again, compartmental fire. So compartmental fire is again, we will call that as a compartmental fire. Now, what will be the color of fire? So there are various colors. So you can see different colors of the fire. Some will be very black and some will be reddish, and whatever, it's basically the fuel which is burning. So if the material which is burning, so it depends on, depending on that, we will have various color for the fire. Now, simple rule. So that is the starting point where we will see what are the various rules for the fire evaluation of steel structures. Yeah. So the first thing, there are various categories of steel structures. So let's say a building is subjected to fire, a steel structure is subjected to fire, and how we are going to assess each and every member. So we may get various categories of buildings. So the first category is some of the members may be straight, and that appears to be unaffected by fire. So by visual observation, we can see that some members are not badly affected. The shape is very straight itself. So including those having very slight distortion and not visually observable. So such members, we need not do anything. We can just retain them. So even after a fire incident, when we are evaluating the structure. Now, we have second category of members. So that are having noticeable deformation, but that could have been done due to the heat straightened or slightly mechanically straightened. So if you can mechanically straighten those members, we can repair and retain or reuse them. So after the fire incident, if there is a very slight deformation, we can just take out that member, straighten it by means of heat treatment or mechanical force, and we can just use it again. And there is a third category where the member will be severely deformed. So we cannot get it back to its original shape. So then it will not be economically feasible to use that member. So when compared to the cost of replacement. So in such a case, we will remove those members and replace those members with new members. So again, that is another advantage when we are going ahead with steel structure. We can replace individual members and replace them with new members. So that is how we will do the fire evaluation. Now, what are the positive points of steel as a construction material in fire? So we already told steel is more susceptible to fire, but there are some positive points for steel also. So damage to strength of steel due to fire is reversible in most of the cases. So that is one aspect. So even though fire is getting affected, so its property will reduce, and in most of the cases, it will be reversible back to the original state if it is in the elastic limit. Then we can use the principle. This is one of the basic principle which by means of visual observation. So if the member is straight after the fire, there is no deformation. So the steel is okay, and many members could be salvaged. So we can just reuse that member. No need to worry much on that. So up to about 200 degrees Celsius, 200 to 15 degrees Celsius, the steel will remain its strength. So it will not get affected with minor change in temperature. Around 200 degrees Celsius, nothing will happen to steel. Beyond that only, all these properties will get affected. So in the case of concrete, we know that at 235 degrees Celsius, the concrete turns pink, 590 degrees Celsius, it will turn to red, and after 600, it will be irreversible damage. But even though steel temperature is more than 215, it won't cause much damage, so we can reuse it. Steel exposed to 600 degrees Celsius, we can strengthen and we can reuse that. So that is one major advantage, and individual members can be reused. That is another point where the steel plays a major role. Now, fire resistance period. So the purpose of setting a fire resistance period is to ensure that in the event of fire within a building, the load bearing capacity of the building will continue to function until all occupants have escaped or being assisted to escape. So already I pointed out this, when there is a fire accident, we should have sufficient time for escaping. Now, the temperature in the standard fire rises quickly and then increases indefinitely. In the real fire, it is not the case. So once the combustible material has been consumed, the fire will decay or move. So this is a comparison. So if you are simulating a fire accident, so what we will do, we will increase the temperature. So that means that is a standard fire. So the red color shows how the standard fire will be. So the temperature keeps on increasing, just like that. Upon time, it will increase. But in reality, whenever there is a fire accident, what happens actually is the combustion will continue till the entire fire load is consumed. So all the combustible materials are over, means the temperature gradually reduces. So you can see here, so around 30 minutes, the real fire, the temperature will reach 800. After that, all the combustible materials are being consumed and the fire will reduce gradually. That is how the behavior of the structure will be when it is subjected to fire. Now, so these are some of the guidelines given by BS for 9999 table 25 for various occupancies, various types of shops, assemblies, everything. We can see here, when the height of the building is less than 5 meters, 30 minutes is the fire resistance period. So it will be 60 minutes. It should be 60 minutes when the height is less than or equal to 18 meters. And as the height increases, we should have more fire resistance period. Why? Because we need more people to escape the situation. So less than or equal to 30 meter, that means it's a 6-story, 7-story building. So we need 90 minutes minimum to save the people. And there is another guideline. If the height is greater than 30 meters, you should have sprinklers. So you might be familiar, in multi-story buildings, sprinklers are available where water will be sprayed so that it will control fire to an extent. So various occupancies, we can see here the various fire resistance period. So if you see a car park, it's an open car park, means in less than 15 minutes people can escape. So that is what that is how we will set the fire resistance period of various structures. So now we will see the various fire protection systems. So fire resistance period we know. Now we will see what are the various types of fire protection systems. So the first thing is a thin film intumescent coating. So it's something like paint. So you will be painting the steel structure. So similarly, it's a paint-like material which are inert at low temperature, but it will provide insulation as a result of a complex chemical reaction at temperatures of approximately 200 to 250 degrees Celsius. So if you provide such a material, it will control the temperature of the steel structure to an extent. As the coating reacts, it swells to provide an expanded layer of low conductivity char that insulates the steel section. So it will basically act as an insulator. So now these are some figures of an insulated coating, intumescent coating steel structure where that is being sprayed. So you can see another figure, a person spraying this intumescent coating over the steel structure. So it will control fire to some extent. It will increase the fire resistance period to an extent if you use fire protection system. So again, we can have boards. So these are broadly two families of broad protection, lightweight and heavyweight. So these are nothing but some boards. So cardboard, you might be familiar with cardboard. Similarly, we will be having some inert boards which will be inert to fire, and we will cover the structure with those types of boards. So we can have lightweight and heavyweight boards available. So using those boards, so it will actually prevent the direct contact of fire with the steel structure. So again, BS code suggests the board thickness for 30 minutes fire resistance period, 60 minutes and 90 minutes fire resistance period. What should be the thickness of the board should be used. So that is about the boards which will be used as fire protection system. Again, we can have partial protection. So this is one figure which is showing a steel concrete composite beam. So the red figure is a steel section, which is an I section, and the other one is a concrete slab and beam. So if you use a composite steel structure, to an extent, it will provide, it will avoid the direct contact of the fire with the steel structure, and concrete is bit more resistant than steel. So it will protect the steel to some extent. And also there are cases where the steel section will be completely covered. The steel beam will be completely covered with concrete so that it will be fully prevented from direct contact of the fire. So this is a figure showing partial protection. So such measures are actually partial protection where the concrete will also contribute to the strength of this member. So these type of members are known as composite steel concrete composite constructions. Now coming to the design, how we will design for fire. So if you see IS 800/2007, there is annexer G which will say about the fire resistance period and all. Beyond that, we don't have much provisions in IS 800. So, but if you see Australia New Zealand Code 4600/2018, so in section 9, it has given some of the guidelines for fire resistance. So thin-walled steel CFS structural members have a high exposed surface area to mass ratio. The temperature development in these members are likely to be rapid and high. Hence, they are often located within or protected by fire resistant barriers when they are required to have a fire resistance level. Okay. So we should have an adequate protection. So that is what IS code says, sorry, not IS code, Australian code says. We should have fire resistant barriers that will protect the structure so that the fire resistance level can be elevated. The protected cold form steel structure shall be designed to have a period of structural adequacy equal or greater than the required fire resistance level. So when you design, so period of structural adequacy means how much time the structure can resist fire. So it should be always greater than the equal to or greater than the fire resistance level of the structure. Now, what are the various provisions given in the Australian code for the design of fire? As we know, the yield strength, the modulus of velocity will be getting affected by fire. So this Australian code has given elevated temperature, mechanical properties for fire. So how the yield stress will vary with temperature. So there are two expressions provided in Australian code AS 1397, so which is already also adopted in Australian New Zealand code 4600. So up to 20 degree to 300 degrees Celsius, you can see FYT by FY20. So FY20 is actually the ambient temperature yield strength. So that means 250 megapascal is the yield strength of the steel. Means if you want to find the yield strength at any temperature, you can use this expression. Up to 300 degrees Celsius, if you substitute the temperature over here, you will get this Fy at that particular temperature. And there is another expression which is given for 300 degrees Celsius to 600 degrees Celsius. So similarly for low strength steel, so there are two expressions available. One is for high strength, that is steel grades greater than 400 megapascal, and another one is for low strength steel, one less than 300 megapascal. So there are two expressions available in the Australian New Zealand code. So where Fy at T is the yield strength of steel at T degree Celsius. Any temperature we can substitute up to 600 to 800 degree Celsius, and we can obtain the what is the yield strength of steel. So this is how a graphical plot of these expressions will be. So as the temperature increases, so this factor, this is actually the reduction factor. You can directly take from this factor at one particular temperature. You take this factor and multiply with the yield strength of the steel. So you will get the yield strength at that particular temperature. Similarly, there is another expression for variation in modulus of elasticity with temperature. We know that at ambient temperature, the modulus of elasticity is 200 gigapascal. So now compared to the ambient temperature, that is E at 20. So we can evaluate the modulus of elasticity at any temperature. So again, there are two expressions for all the steels available up to 300 degrees Celsius. You will have one expression, and the next expression is for 300 to 600 degree Celsius. So this is how the graphical plot will be. So again, the reduction factor can be directly obtained. So when you multiply the reduction factor with 200 gigapascal, you will get the modulus of velocity at that particular temperature up to 600 to 800 degree Celsius. Now, Euro code. So Australian code we have just seen. This is how the Australian code deals with fire. Now, when you see European code, they have directly said with one word. The techniques described in EN 1993-12 2005 for hot rolled steel. Whatever the design provisions for hot rolled steel, that can be applied for cold form steel members also. That is what the Euro code says. So hot rolled steel members, same like the Australian code, they have provided expressions for the modulus of velocity as well as yield strength for various types of steel when it is subjected to fire. Now, American code. So this is another code. These are the three major codes where the world follows. AISI S100. So material strength at elevated temperature. So in the absence of any test data, it is permitted to use the material properties stipulated in this section. I will just show you what is that section. So this relation do not apply to steel of yield strength that exceeds 450 megapascal. So in the next slide, I will show you what is the relation which is shown in the AASI code. So AASI code also specifies the thermal elongation for structural and reinforcing steels for temperature above 150 degree Fahrenheit or 66 degrees Celsius. The coefficient of thermal expansion value is also given. Okay. So the mechanical properties at elevated temperature. So if you see this table, so you can directly get this is table 4.2.1 of AASI S100. where at different temperatures, degree Celsius, you can see these are the factors which we need to multiply with the uh, normal temperature yield strength, plastic strength, ultimate strength, E modulus of velocity, and G shear modulus. So all these values, so Ke factor, Kp, Ky, and Ku. Ku means ultimate strength. So all these values directly we can take these factors if you don't have any other test specified values. So you can use this ambient this ratio in order to evaluate these properties at elevated temperature. That is what the American code says. Now, this is one particular steel. This is an experimental data where the 280 grade steel, how the stress strain curve of the steel will behave with increase in temperature. So you can see the first one is actually the 200 degrees Celsius. So up to 200 degrees Celsius, there won't be much change in the mechanical properties of steel. So, and you can see the initial elastic phase, then it's a continuous yielding and all. But as the temperature increases, let it be 400, 300, 400, 600 and all, you can see how the material property degrades. So you can see here, initially there was a upslope. Once the temperature reaches 600 degrees Celsius, there is no physical improvement in strength beyond a point. So the strength also reduces drastically. So initially we had 250 megapascal, and once the temperature increases to 600 degrees Celsius, your yield stress has reduced to around 60 or 70 megapascal. So that is how steel will get affected by this temperature rise. Now, modulus of velocity, how that is getting reduced for this particular grade of steel. This is also an experimental data. So we know what will be the yield modulus of velocity at ambient temperature. That is around 2 or 2.1 gigapascal. So this at room temperature, we had 2.1 gigapascal. Up to 100 degrees Celsius, there won't be much change. You are getting okay. The value is okay. And once it exceeds that 150, 200, if you reach the steel property, even nowadays for some of the steel grades we are getting 1.8, so 1.8 gigapascal or 180 gigapascal. So up to 200 degrees Celsius it is okay, so we can have the same material property like the normal steel. But beyond 200 degrees Celsius, you can see how the modulus of velocity has drastically reduced. So that is how it is getting affected. Now, this is another graph showing the thermal expansion. So this is not much relevant in our context. So specific heat, this is another property of this particular grade of steel, how it is getting improved when increased when the temperature increases. Thermal conductivity, another property of the steel which is getting affected by the temperature, right? So now coming to the last part of our lecture, that is analysis techniques. So we have seen a lot of cases how the fire is getting affected, but as an engineer or as a researcher, so we need to see how the strength is getting reduced. Or if you take an eye section, and if I increase the temperature to 500 degrees Celsius, how the strength will get affected. So there are basically two methods by which this is basically for researchers, those who are working in this area, or those who are planning to do. So there are basically two types of analysis. One is known as steady state analysis, other one is transient state analysis. So it's a quite simple thing. So by means of steady state analysis means, if you want to study the behavior of a steel section at 500 degrees Celsius, what I will do is I will heat the steel to 500 degrees Celsius. I mean, I will keep that steel specimen inside an oven, and I will increase the temperature to 500 degrees Celsius, take the specimen out, test it in an UTM or any other testing facility. We will evaluate its strength. So that means we will heat it first, then apply the load and get the strength. So that is the way of evaluating the strength of steel by means So which one is more appropriate? Of course, if you see a realistic scenario, a building is catching fire. So we have a column. So already that column is subjected to some sort of loading. So what will happen? It is actually a temperature rise. So once the temperature rises, the column will get affected, beam will get affected. So if you want to experimentally or analytically simulate the effect of a steel structure subjected to fire, we have to go ahead with transient state of analysis. But coming to the experimentation part, it is really difficult. So if you have an UTM, you can somehow increase the temperature of the steel, place it in UTM and test it. So that is steady state. But if you want to go ahead with transient state analysis, what you need to do, you should have an UTM, and once the structure is loaded, after that you need to provide an oven and increase the temperature. So that is how the transient state analysis works. But more realistic, and it will simulate the real life condition. So that is the basic difference between steady state and transient state analysis, where a lot of researchers are working on both these areas. So now I will quickly go through some of the steady state and transient state analysis which we have done. So, and from some research papers, we have taken some of the data and we have done our own analysis also. So, of course, if you go ahead with experimental procedure, it will be costlier and a lot of time for experimentation and all. So we can do all these things by means of finite element analysis also. By means of various finite element analysis techniques, we can simulate both the steady state as well as transient state condition for fire effect on steel structures. So FEA. So this is actually a study on material study by observed in literature for FEA of steady state and comparison with one particular literature. So what we will actually do is we will calculate the elevated material properties of steel structure. So at 500 degrees Celsius, what will be the material property of steel structure? So in finite element analysis, we will input the stress strain curve at various temperature. So generally in FEA, what we will do, we will use one particular stress strain relation. Now, if you want to study the elevated temperature, it's something like one analysis I will do with 200 degrees Celsius, another one 20 degrees Celsius, another one 300 degrees Celsius. Keep on varying the stress strain relation. So it's normal analysis only the material property keeps on changing. So such an analysis is known as a steady state analysis. So this is one particular channel section which has been analyzed using this method. So it's subjected to moment, and the column beam is subjected to moment at both the ends, and the behavior of the beam is studied. So these are various assumptions used in the nonlinear analysis of the structure. That is not much relevant. I'm just going to show you how that is being done. Okay, so of course, if you do a finite element analysis, so this is an experimental data available in the literature. So using finite element analysis, we have compared the strengths. So ultimate moment carrying capacity of the our analysis with the experimental procedure. So we got a closed simulation less than the error value less than 10%. Similarly, the transient analysis also can be done using finite element method. So this is again a validation of an experimental study by Cravero et al. So where a lipped channel column is subjected to transient state thermal analysis. So these are the material properties. So here what we will do is for this column, we will apply an initial load and we will increase the temperature of the structure. So that particular analysis is known as coupled temperature displacement analysis. Using that analysis, we will increase the temperature surrounding this column so that at one particular temperature, the column will fail. So it will be preloaded to some load. So at what temperature the column is going to fail. That is what we are going to analyze by means of this steady state analysis, sorry, transient state analysis. So these are the boundary conditions which are used. So load, initially we applied around 30% of the design compressive load on the column, and static risks analysis will be used for applying that load. Then we will be using the temperature displacement analysis. So this part is okay. So the Yeah, we will be giving input for various properties like thermal conductivity, thermal expansion, elasticity, plasticity, etc. So, and temperature load. So we don't know how the temperature has to be applied. So there is a standard fire curve which is available, that is known as ISO 834, which is a standard fire curve which will simulate the real world fire condition. If there is a fire attack, how it will spread. So that time versus fire curve, temperature curve is available. So using that curve, we will be giving the fire. This is a ISO standard fire curve that will be simulated using the model, and that will be given as input. And this is how the comparison with the experimental results, how the experimental study and the numerical study can be compared for various cases. So we will be getting the maximum temperature at which the load will be maximum. So that will be known as the peak temperature of fire resistance, and the temperature at which the structure fails is known as critical temperature. So if you are doing a transient analysis, these two are the important terms. What is meant by a critical temperature, and the other one is a peak temperature. Okay, so that is giving you an overall idea about the transient and steady state analysis. Okay, so these are all the things which I would like to cover. So this will be my last slide, and my email ID is there. So thank you so much. If you are having any questions to be addressed, I'm happy to answer. Thank you.
Thank you, sir. Let's open the floor for questions. You can unmute your mic and ask your queries, or type the questions in the chat box, and we will discuss the later. Some questions are in the chat box.
Yeah, I will
First
just.
one.
I will
what are
read
the
that.
methods? Okay.
Yeah, what are the methods that can be used to retrofit steel members for fire protection? So retrofitting means how we will strengthen the steel structure. So as we see concrete, we will retrofit by using various techniques. But steel, we may not have to use that. That is what I have told you. There are one way we can just take out the material, use some mechanical force. So you can just try to make it to a straight shape. So if the shape is retained, it will still carry the load. And if there is only slight deformation, some temperature treatment. If you apply the temperature in the opposite direction, the material will come back to its original shape. So if you can able to replace its original shape, that can be done. Okay, so we can replace and use the same steel section. And suppose if the member is severely damaged, so we need to, of course, remove that material and replace new material. So there is no such idea like we are attaching one more member and increasing the strength. Generally, that is not the practice. Okay, so that is how we will retrofit the steel members. So members, so materials used for board protection. So I'm also not quite familiar what are all the various materials, but these are some composite materials. So some like FRP composites, or some what are those things, that cement plasters. If you are having a cement based composite, so that will generally provide some sort of protection to some cement plaster boards are good protective methods which can be used for these boards. Okay, so again the next question, what are the effect of elevated temperature on fasteners and connections? Yeah, fasteners and connections, they are the weakest link. uh, Generally I don't have much idea how that is getting affected, because again the fasteners are complex. So if the fasteners are getting affected, uh, uh, only thing we need to replace. So if welding will get affected, definitely if there is a direct fire accident on a member, we need to do the welding again. Welding means it is easy to do, but if there is a bolt failure, we can replace the bolt if possible. or in other cases we need to cut the member, provide a new set of bolting arrangement. That is one advantage we can just use. So if a part of the structure, say for example a beam column connection is getting affected by fire, so that part is severely affected, so we can cut a portion of the beam, portion of the column, so remove that part entirely, so splice the beam with the additional member and splice the column also with additional member, provide a fresh connection. So it is not a good idea to retrofit or replace a part of the connection if it is severely affected. Okay, so that is my take on that particular question. So the next question is, what are the advantages of glass fiber reinforced concrete bars compared to GF GFRC, glass fiber reinforced composite bars compared to mild steel with respect to fire attack? So unfortunately, I'm not having much idea about GFRP. Of course, GFRP will provide better resistance. So how they will behave in fire, I have not looked into. So they have a better resistance to tension, compression, all these things are familiar. So how the behavior will be when it is subjected to fire, not having a good idea. Probably it is a good topic for doing research. So not much people have done studies on glass fiber range. Now composite bars, GFRP bars are commonly used for certain applications because of its corrosion resistance and all. But I am not having much idea how they will behave when it is subjected to fire or increase in temperature. That's a good area of research. Yeah. Any other questions? So thank you so much. So if somebody is interested in doing some of the research related to all these topics, you can contact me through my email ID. Thank you so much, madam.
Thank you so much, sir. Sir, actually, it was a really insightful session and very informative. Thank you so much, sir. Now, the feedback link will be shared through the WhatsApp group and the chat box. All of you, please fill this feedback.
Okay, thank you, ma'am. I'm leaving the meeting. Thank you.
Okay, thank you, sir. Naveen, sir, are you there?
Hi, yes, I'm here.
Yeah. Okay, sir.
Can you hear me?
Yes, sir. It's audible.
Yeah, thank you.
Now, let's move on to the next session. We are delighted to welcome our esteemed resource person, Dr. Naveen Joseph, who is joining us to share their experience on the topic water scarcity, drought vulnerability, and flood-related disasters. He is an assistant professor at the Department of Geospatial Science at the Radford University. He finished his PhD in the environmental hydrology and water resources at the University of Melbourne, Australia. He worked as the postdoctoral research fellow at the University of Idaho, USA, where he also served as an interim director of the Idaho Water Resource Research Institute. His research interests focus on understanding the interactions among humans, the geospatial environment in which they live, and the public health. He primarily uses geospatial datasets, statistical tools, and hydrological models to address the water resources issues both at regional and nationwide scales. His research themes include large-scale and catchment-scale water resources modeling and investigating the relationships between the environmental contaminants such as pesticides and human health outcomes such as cancer. Once again, I welcome you, sir, and the floor is yours. Sir, please.
Yeah. Thank you once again. I will share my screen before I start.
Okay, sir.
Okay. Let me know um, if you can see my screen in
Yes, sir. You can make it the
slideshow mode.
slideshow.
And if I move the slides, you can see the second slide too.
Yes, sir.
That
It's
sounds
okay.
great. Yeah. Thank you once again for the kind introduction. I would like to sincerely thank IES College of Engineering Thrissur for the organizing committee and the FDB coordinators for this kind invitation and for organizing this timely faculty development program. I know these programs are crucial in strengthening our capacity to address challenges through teaching, research, and professional practice. In today's presentation, I would like to talk about water security and sustainable infrastructure development. And when I talk about water security, I would like to talk about water scarcity, floods, droughts, etc. When you talk about water security, it's no longer a hydrological or a supply side issue. It's basically connected to climate extremes, urbanization, infrastructure planning, public health, socio-economic stability, etc. Across India and global level, we are witnessing floods, we are witnessing increasing droughts, water scarcity in several regions, and often driven by unsustainable infrastructure and poor integration of natural systems. As engineers, planners, and academicians, we are positioned to influence how can we manage drainage networks, water supply, flood control structures, urban layouts, etc., to connect availability, extreme events, and infrastructure sustainability. To this point, I would like to briefly talk about my research in the context of water security, sustainable infrastructure development, and feel free to stop me if you have any questions in between. And at the end, if you feel like if you want to reach out to me for any questions, that's also perfectly fine with me. Myself, Naveen Joseph, I'm an assistant professor at the Department of Geospatial and Earth Sciences at Radford University in Virginia. Why water scarcity or water security is a concern? So, when you talk about water security as sustainability concern, the first thing comes to our mind is sustainable development goals. So, there are 17 sustainable development goals put forward by the United Nations, out of which the sixth one being clean water and sanitation. And when you talk about the clean water and sanitation, that is actually connected to multiple goals. For example, no poverty, reduced inequalities, sustainable cities and communities, or zero hunger, good health and well being, etc. So, in effect, when you are achieving water security or water and sanitation goal, you are indirectly achieving partially or almost 30 to 40 percentage of some of the other goals. That's important for us. So when you are designing an infrastructure, if you can achieve clean water and sanitation, you are basically achieving many other goals as a byproduct. And if you look at global status, drinking water, there are significant issues. 73% have safely managed drinking water, which means that approximately 27% is still facing drinking water concerns. Wastewater, only 58% is safely has safely treated wastewater. Accessibility, water quality only 60%. Transboundary issues, most of you are aware of several transboundary rivers, especially from our state borders, especially from our nation borders, or at the global level if you look at the polar regions, etc. Transboundary concerns, cooperation, efficiency, water stress. So, what can we do to manage these infrastructure to ensure that these issues, existing issues, can be resolved to a larger extent? And when you talk about water security again, a recent study published in 2021, when you look at water security, most often people look at water security through different lens. Here is a word map. When you look at this word map, you can see resources, climate change, poverty, emotional distress, food insecurity, vulnerability, challenges, governance, countries. So these are some of the keywords, and all of this need a sustainable infrastructure development to address this water security. So my research area being water security, so I predominantly focus on water security and how it interact with other variables present over here. When you look at clean water and sanitation again, Sustainable Development Goal 6, are we at the point where we have clean water and sanitation throughout? No. When you look at sustainable development goal achieved, only very few countries have achieved it. Many other countries challenges remain. For India, it's significant challenges remain. Major challenges remain in African subcontinent, the Mexico, South American region. So there are globally there are several challenges when you look at clean water and sanitation. And in early 2000, Arjun Bhai Hoekstra, who is considered as the father of water footprint, he introduced a concept called footprint of water. What is the volume of fresh water which can be used to produce a product? And when you talk about water footprint, people sometimes compare water footprint with water use and misrepresent water footprint. Because water footprint is summed over various steps of the production chain. It has a spatial and temporal dimension, meaning that the product which you are consuming here might be produced from a place which is from a different state back 2 years ago, and it's measured in terms of water volumes consumed, evaporated, or polluted. And why we are concerned about water footprint. When you look at water footprint, the fresh water available for use is only 1%. And is the fresh water uniformly distributed across the world? The answer is no. In 2011, again, Hoekstra and one of his collaborators, Mesfin and McConnell, published a paper which looked at water footprint across the world. And they found that several countries, especially the North American continent, is more or less water stressed, or there is enough water available. However, in Asian subcontinent, you can see that water scarcity starts popping up, especially at the rate of 1000 to 1700 cubic meter per person per year is the availability. So that's a concern with respect to availability. And with respect to demand, yes, we have recreational use, industrial use, irrigation, agricultural, domestic, thermal power, nuclear power, etc. And those vary across the places too. So there is a need to plan for sustainable infrastructure for freshwater use, and which needs to consider where are the products being produced spatially and temporally. Let's take an example of a animal product. At the consumer level, an animal product is consumed and it has a direct water footprint. If you go back in space and time, there is a retailer involved which has a direct water footprint to manage this product. There is a food processor involved, go back in space and time, go back in space and time again, livestock farming, and again, feed crop cultivation. So although we are only seeing the water used at the consumer level, it's actually inbuilt memory from feed crop cultivation. So when you are designing sustainable infrastructure, we need to consider these factors. What is the amount of water being used or polluted while producing this product? And that's an important aspect because we need to develop policies, we need to develop management practices to address these concerns. So, what is the water footprint of coffee? Any thoughts? and 1 cup of coffee. So 1 cup of coffee corresponds to approximately 140 liters of water. And that's very tricky because 1 cup of coffee is actually 125 ml of coffee, which has 7 gram of roasted coffee on an average, which corresponds to 140 liters of water because this 7 gram of roasted coffee was produced from a coffee plant and then it was converted, processed, and then it reaches the consumer level. So 1 kg of roasted coffee is 21,000 liters of water. The same way, when you look at other aspects, if you look at the 1 sheet of A4 paper, 10 liters. 1 kg of tomatoes, 180 liters. 1 kg of leather, 16,600 liters. Or 100 gram of chocolate, 2,400 or 2,400 liters. So when you look at this water footprint, it is very huge. When you think about when you are using an A4 paper, you are actually using 10 liters of water. So your infrastructure concerns almost increase double, triple, or maybe 4 or 5 times because you are looking at water usage from the beginning of the production stage to the end of the production stage. Sorry. So the water footprint can be assessed in two different ways. One is top-down approach. So when you are designing an infrastructure, you need to understand what is the water footprint. The top-down approach would be the total domestic water resources plus how much water is imported. When you are importing a product, you're importing water from a place. How much water is exported? When you are exporting cotton, let's say cotton to Europe, you are actually using the water in India, but you are exporting to, let's say, European Union. Or a bottom-up approach. What are the products in our place? Sum it up together, multiplied by the respective product footprint, and you will get this is the top bottom-up approach giving water footprint. And when you look at nationwide water footprint, US leads per capita water footprint with the rate of 2,500 cubic meter per person. India follows by around 1,000 meter cube per person. China is around 700 meter cube per person. In terms of total volume, China has the max. China and India has around 1,000 billion cubic meter. US is around 700 billion cubic meter per year. And what is virtual water? When you look at the amount of water that is embedded in food and products, which is needed for its production. And if you look at some of these arrows, you can see that US is in green color, meaning the virtual import is negative or US is exporting a lot. Means that more or less significant water is exported from United States, from South American places, from India, because India has a lot of products which is exported to other places. So even though we are not using that product, our water is being used to produce that particular product. And what are the different types of water footprint? Blue, green, and gray water footprint. The volume of fresh water that is evaporated from global blue water resources, either from surface water, groundwater, to produce goods and services consumed by the individual. That's blue water footprint. While the green water footprint is the volume of water evaporated off, let's say rainwater. And the gray water footprint is the volume of polluted water that is associated with a product. For example, when you develop a crop, some of the water is being polluted. How much fresh water you need to add to that polluted water to dilute its concentration so that it meets the standards, the water quality standards. That's a great. So when you look at the volume of fresh water consumption of fresh water or groundwater, the blue water footprint is significantly high in India because you have a lot of irrigation, especially in the northern parts of India, and it's incorporated in the product. It's not returning to the catchment area. So when it has a spatial component, so when you are designing an infrastructure or when you are managing a water resources place, you are looking at water footprint magnitude varying spatially within a state, within a country, etc. And if you look at United States, from west to the east, so this shows the blue water footprint for different crops. For example, oil seeds or other crops dominate on the western part of the United States, while the central part is dominated by cereals. And then you have service providing industry, the purple color. And when you look at the eastern part, you can see a variety of industries, livestock, thermoelectric power, vegetable starts dominating. So when you are planning for a design, you are looking at a variety of options or a variety of spatial distribution of water footprint crops, production, population type, all the other factors. And when you talk about green water footprint, it's a consumption of water that refers to the precipitation on land that does not run off or recharge groundwater because it's from the rainwater. And you can see that especially the eastern part of the United States is significantly high because there is more rainwater over here. So rainfed crops are here. In India, also some of the portions, especially in the southern part of the India, you can see that there is an increase in green water footprint. So it's evaporated off or transpired from the plantations. And gray water footprint is the volume of fresh water that is required to dilute the load of pollutants. It's usually calculated as the volume of water that is required to dilute pollutants so that it meets the water quality standards. And when you look at the blue, green, and gray water footprint, they are different. And essentially, the total water footprint is a sum of blue, green, and gray water footprint. And if you look at the European Union impact on blue water resources, let's say cotton consumption. European Union is consuming cotton. And when European Union is consuming cotton, India is exporting around 25 to 2,500, 2,500 million meter cube per year. Many other places are exporting around 500 to 700 million meter cube per year of water. So even though European Union is consuming cotton, the water comes from different places. So that's important for infrastructure development. When you look at green water footprint, yes, rain-fed crops, rain-fed cotton, around 3,500. India is the dominant one. US also has, especially the eastern part of the US, around 200 million meter cube per year of water is being exported to the European Union aspect as well. And when it comes to grey water footprint, again, India has the highest one, around 700 million meter cube per year, which is coming to the European Union as well. And when you look at the total water footprint, which is the blue, green, and gray, and you can see that Indian subcontinent is actually in the red zone, 500 to 1,000. So when you are designing an infrastructure, even though I have not touched the infrastructure design yet, you are looking at varying spatial patterns. And that's why you cannot have a simplified all fit for one approach for across the world because you have different spatial distribution of water footprint, blue, green, gray water footprint. We are looking at only one aspect of it. And within that aspect, you have a variety of options over here. And that's why we need to consider these factors while designing blue, green, and gray water footprint. And if you look at blue, green, and gray water footprint by different rivers, for example, Mississippi River is in the United States leading high green water footprint, the green color one, blue water footprint, the range of around 50 to 10 billion meter cube per year. Grey water footprint in the range of around 100 million meter cube per year. From Ganga, you can see that around 250 million meter cube per year is the green water footprint, blue around 250 to 350 or 360, 110 million meter cube per year, and then approximately 50 to 70 billion meter cube per year for the grey water footprint. And then you have Parana River, Yangtze River, Nile, Indus, Krishna, Godavari, all these rivers contributing to the water footprint. So you are not just talking about water footprint assessment for regions, you're talking about water footprint assessment for rivers as well. And why are we concerned about this? When you look at the water cycle and sustainable development goals, you have this drinking water concern, you have the sanitation and hygiene, you have the water quality and wastewater, you have the cooperation and participation, you have the water resources management, you have the water use and scarcity, and then you have the water related disasters as well. So, for all of these, it's very important for us to consider water cycle and sustainable development goals. And water footprint assessment is essentially to check, analyze whether water use is environmentally sustainable, resource efficient, and equitably allocated. So, to be environmentally sustainable, water use should not exceed the maximum sustainable limits. If it is exceeding, it means that we are depleting the available freshwater resources through or through ground. Sustainable water use measure we can quantify using different measures. One of the indices is blue water scarcity. It is a measure of blue water footprint compared to the water available after considering environmental flow requirements. So what is environmental flow? The flow that is required to ensure the ecological requirements, the aquatic life, or to the floodplain requirements. So if the blue water footprint is more than available water, which means that your available water is not enough to meet the existing demands, you cannot allocate for environment. And that would lead to ecosystem degradation as well. To this point, we wrote a review article. How can we analyze the sustainable water use at global to continental scale? And we tried with multiple frameworks. And one of the frameworks which we came up with was sustainable water use measures, a function of available water and water use. And here, available water can be defined as sum of surface water and groundwater, while water use can be sum of irrigation, industrial, domestic, environmental water demand, etc. And the challenges are, how do I come up with some numbers for these variables? For irrigation, you need so many variables, cropping data sets, county-wise water withdrawal data sets, irrigated area data sets, and you apply different kind of models to calculate or estimate these irrigation water uses. Similarly, for industrial water use, multiple models are being used to compare these economical indicators like GDP or technological indicators and production data. What are the product, how many factories, what are the production in kilogram or production in liters for particular industries, and then you sum it up. Domestic water use, again, you have population as a driving factor because most often population is the largest driver use, and with technological development per capita available water also varies, and you have this more economical technological influence too. And then you have the environmental water demand. How do I calculate how much water is required for environment? It can be done from hydrology based approach where you say that a proportion of the available water, or you can say that this was what the environment had in 1950s where the river was healthy. Maybe we'll try to mimic that. Maybe we'll try to mimic the flows from the past. So there are multitude of options where you can provide for sustainable water use measure as well. To this point, the different indices have been developed by United Nations, one of them being Millennium Development Goal, which defined as water resource abstraction by total renewable water resources. Sustainable Development Goal focus on level of water stress, freshwater withdrawal by available water resource minus environment flow, water shortage, water availability per person, or water stress index, total water demand by total available water minus environmental flow for a particular month or a particular time period or for a particular location or a particular state or a district or a individual place. And there are indicators like water stress indicators, usually less than zero point 0.2 low water stress, zero point 0.2 to zero point 0.4 moderate water stress, greater than zero point 0.4 severe water stress, greater than 1 extremely severe water stress, etc. The same way, water shortage, per capita available water, if it is greater than 1700 meter cube per person per year, which means that there is no water shortage. Or if it is between 1000 to 1700, there is water scarcity. If it's only between 500 to 1000, you are water stressed. And if it's less than 500, you are in absolute water stress. And when you look at blue water scarcity, it's defined as the blue water footprint to blue water availability. And you start seeing that, especially in the northwestern part, Gujarat, Rajasthan region, you can see the darker reddish color zone. You are in blue water scarce zone. And you can see that Kerala is in the zone of 2 to 3, still water stressed, but compared to Tamil Nadu and Andhra Pradesh, which are in the zone of highly water stress region. So when you look at this water scarcity map, you can see that there are variations. And if you look at the United States, the annual values, you can see that especially the western part of the United States is highly water stressed. And this is for annual level. And if I look at by month, in January, you can see that for the Indian subcontinent, Gujarat and Rajasthan are still water stressed. In February, because January we still have some water, in February you are going down with available water, and with increasing demand, most of the India is actually in red color zone. In March, you're slowly starting the summer, the red color zone increases. In April, again, you can see that red color zone is still dominant. In May, again, yes, you can still dominant, but you can see some green dots along the southwestern part of Kerala and the India. And you can see that that's actually a sign of, oh, there is rain coming, there is available water coming up. And if you look at the month of June, where rainwater, where the monsoon actually entered the southeast western part of the United States, you can see that the zones are now moving to the green color zone. So there is monthly variation. And in July, you can see that the monsoon actually moved from Kerala to the central part of the India, and you can see that more places are getting green color zones. In August, yes, you can see that especially the northwestern part also started seeing an increase. In September, you can see that monsoon is retreating back. Monsoon is slowing down, monsoon is going back. And you can see that Gujarat and Rajasthan are going back to red color zone. By October, these places are still less water stressed, but some of the places, especially the southeastern part, Tamil Nadu, Andhra Pradesh are still increasing. And you can see by November, the south central part is dominant, while this zone where we have the northeast monsoon season starts entering. So you can see there is a rise in green color zone. And then in December, going back to the monsoon is retreating back, and then this cycle continues. So when you think about the blue water scarcity, there is spatial variation, there is availability concern, there is demand concern. So whenever you are designing an infrastructure, if I'm just talking about quantity aspect alone, you are looking at water footprint, blue, green, gray, and then you are looking at water stress, blue water scarcity, where you are looking at availability and demand. It depends on population, it depends on economical development, technological factors, depends on environmental factors, it depends on the availability, the rainfall pattern, the monsoon pattern. And it's important that we analyze at a very finer spatial and temporal scale to understand this variation. Having said this, I would like you guys to do a short exercise. Please scan this. If it doesn't work for you, you can also go into this link. Let me know how much water footprint you are having. Please take 2 minutes and just let me know when you finish it, or maybe just give me some numbers in chat box, how much water you use on a daily basis. So one of the participant responded 200 liters, and imagine the magnitude of 200 liters per day.
The sound ഇല്ലാത്ത
Imagine the magnitude of 200 liters. Did anybody else got an answer which is higher than 200 liters?
കണ്ടില്ലേ
220 is here. You guys are doing better than me, actually. In the range, very high.
ഇല്ല.
170, 15 liters. Somebody is using water really carefully.
Sir, could you please post the link in the chat box?
Sure. Thank you all for doing it. So most of you are doing really great, especially consuming at a very good rate, because you know that the questions were very simple, where like you shower, you washing cars, you the way which you using water. So when you look at water footprint, you can see that your impact. So when you think about a person who you think that okay, he or she or they or them is using water at a higher level compared to myself, then you need to design a infrastructure, food, a locality considering all these factors. So, to this point, I would like to introduce all of you to some of my research areas, one of them being water scarcity and one of them being water health nexus. I would like to acknowledge my collaborators from Indian Institute of Technology Madras and from University of Melbourne, University of Idaho, Northern Arizona University, and University of Nebraska Lincoln before I talk about my research. In water scarcity research, Indian Institute of Technology Madras Professor K.P. Sudhir and University of Professor Dongrio Rio, Professor Hector Milano, all of them contributed to the water scarcity across the whole of India. And when you think about the whole of India map, you can see that there is 18% of the world's population, and now it's more than that, with 4% of the world's water. There was a paper in 2016 which reported that 4 billion people are facing severe water scarcity, and 1 billion is from India. Northwestern India is characterized by critical groundwater depletion. 54% of people is moderate to severe, extremely severe water stress. The available water has fallen down from 5,000 to 1,500 meter cube per person per year over a span of 60 years. So, what does this indicate? The water availability and water demand has been increasing in the past, and India, if you look at state by state, there are variation. And we developed a framework which calculates as the ratio of to available water. Available water is sum of surface water and groundwater. We use a community land surface model to calculate the water demand, water availability. For water uses, irrigation, industrial, domestic, and environmental water demand using census data sets and hydrology-based approach. And we calculated at state level and monthly scales. For example, industrial water use. When you think about industrial water use, the availability of industrial water use across India is very, very scarce. And we used different models to calculate this industrial water demand from state level and national level availability. And when you look at some of the states, Maharashtra leads industrial water demand with around greater than 4 billion cubic meter. And we published this article in Resource Conservation and Recycling in 2019, 6 years ago, calculating the industrial water demand. So that was our start. So we have the industrial water demand, one of the first studies which calculated industrial water demand across the whole of India, which gives state by state, month by month industrial water use for whole of India for a span of 1982 to 2010, around 30, 29 years, sorry, 29 years of span. The same way we recalculated domestic water use. Here, we did not just use per capita water use multiplied by population. Instead, we modeled the per capita water use because per capita water use has been changing over the past due to economical, technological indicators like GDP, etc. And we modeled total domestic water use and we published in Urban Water Journal 4 years back, looking at the statewide and monthly domestic water use for a longer period from 1975 to 2050. These time periods were selected predominantly due to data constraints. And if we had more data, more reliable data available, we would have gone back to more longer time periods because of the space time constraints, data constraints. We were looking at around 1975, 2015, which is still around 41 years, which is really good, and monthly data. So 41 times 12. So it's coming down to around 410 plus 82, 492. So we use the Millennium Development Goal 7.5 by the United Nations 2000, water resource abstraction by total renewable water resources. In 2015, United Nations updated by Sustainable Development Goal, which focus on clean water and sanitation, looking at water stress as the ratio of total water demand by total available water minus environmental flow Here, I and J are for each month and each state, etc. And what are our results? And if you look at our results, water stress index, which is defined as the total water use by total available water minus environmental flow, and per capita available water, total available water by total population. And you can clearly see that the Gujarat, Rajasthan, Uttar Pradesh are significantly water stressed. If you look at per capita available water, Maharashtra starts popping up at the highest level because of high population, while Uttar Pradesh is water stress, but not in the per capita available water because Uttar Pradesh has significant irrigation bottleneck. So when you look at this spatial variation, even at state level, you can clearly see signs. At the eastern part, where you have more available water due to rainfall, you can see that water stress index or water availability is not a very big concern. We published this study in Journal of Hydrology, one of the important publications coming out of this study, coming out of the research, focusing on water scarcity across the whole of India. We did not include Jammu and Kashmir due to several data constraints and due to several political constraints as well. And let's look at water stress index versus per capita available water. So the x-axis is per capita available water. So the lower means bad, higher means good. The y-axis is the water stress index. Lower is good, higher is bad. So our sweet spot or our concerned area is this particular region where low per capita available water and high water stress index. And this particular place, if you look closely into that particular place, you can clearly see that average per capita available water from January to December, and when you can see that per capita available water increases, especially June, July, August, September, due to the summer monsoon season. Most of you are aware, especially when the rainfall comes by, you have more available water. And at the same time, we can see that water stress is low because you have available water, so there is no stress. But when you look at the summer months, so from January to March, you can see that the availability is very low. At the same time, water stress index is very, very high in the range of 1 to 1.5, sometimes going up to 2. And after the summer monsoon, you can see October increasing, then November and December decline. So this is for the whole of India. Again, think about the spatial distribution because spatially we understood that the monsoon is entering from the south western part of the Kerala and then slowly moving through each month. And if we assume that we need to allocate water for environment, then you are actually taking water from the water availability pool. So, in other words, if we allocate environmental flow, you are actually putting additional zero point 0.1 billion people. And that's an ethical question. So, can we afford to allocate water for environment, especially when our major demands, irrigation, industrial, or domestic, are not being met? So without environmental flow and with environmental flow, we have considered that without environmental flow, 41% severe water stress, with environmental flow, 48% severe water stress. And again, imagine that environment is important, aquatic system is important for the future because even though we have to consider a loss for now, the future will be more safe. Reservoir. Reservoirs, what are reservoirs doing? Reservoirs are storing water and they are giving water during the low flow periods. So with reservoir, you can decrease the water stress from 66% to 48%. Or in other words, you can reduce by 0.1 to 0.2 billion people water scarcity by incorporating reservoir component. That's why we have the dams, reservoirs, which are reducing water shortage, especially in October to January, following the monsoon season, where you have less water available from rainfall, but you have storage and use that storage for all the other purposes. And if you look at the month by month low moderate, and severe water stress. You can see that low water stress is high number of states, especially June, July, August. Similarly, severe water stress is very low. But for summer season, you can see that this seasonality actually shift several states into severe water stress. And what are those states? And if you look at those state by state variation from January, February, March, April, May, or if you look at June, you can see that summer monsoon has entered. The severe water stress is less over here, the severe water intensity, but Gujarat, Rajasthan, and still Uttar Pradesh by July, Gujarat is less water stress, Uttar Pradesh less water stress, August, and then September again, monsoon is retreating back, and you can clearly see that up to November, Kerala is still less severe water stress, but then December to January, March, April, May, you have this water stress issues. So even though we are receiving a lot of rainfall, you have these water stress issues, especially due to our topography, even though we have reservoirs, we have all these concerns. And if you look at the annual rainfall from 1991 to 1999, the blue bars, we call it as hydrograph, we can see that this is the annual rainfall around 1000 to 1200 millimeter of rainfall. And then you have this low, moderate, and severe water stress population. You can clearly see that, especially when the annual rainfall is low, your severe water stress population starts increasing. Please note that it's not just annual rainfall. You also have this water stress due to other factors, water demand. So you have to consider those factors too. And if you look at the population stressed, you can clearly see that population is increasing the same way the population affected by water stress in India is around 0.7 to 0.8 billion people are consistently water stressed at least 1 month a year. At least 1 month a year, 0.7 to 0.8 or 0.6 to 0.8 on an app or the minimum value is 0.6 billion people are water stressed at least 1 month a year. And that's important because when you look at this water shortage issues, water concern issues, you need to understand what is the fundamental water concern in those particular regions. So to summarize the research project, so severe water stress were 60% of population, high water stress in Northwest India, low water stress in Northeast India, population experiencing severe water stress at least 1 month a year, 0.62 billion. Environmental flow component, if you neglect it, it underestimate by 10 to 15 percentage. If you include reservoir component, 0.1 to 0.2 billion people. UP has high irrigation water use, severe water stress. Maharashtra has high population density, lowest per capita water, etc. And what can we do with respect to that? So when you look at food grain demand, India, especially after the independence, there were some years where food demand was not very higher than supply, but green revolution, other aspects have increased our supply aspects, so our food demands are being met. However, does that influence our water usage? So to understand this food security and water security aspect is an important component. And now comes the infrastructure aspect. How can we manage watersheds? I'll talk about watersheds in a bit to describe this implementation of land use practices, management practices to protect and improve the quality of water and other natural resources within a watershed. And we need to manage those land and water resources in a comprehensive manner. There are different state-of-art techniques to reduce sediment, nutrients, pollution to the streams and waterways, etc. What is a watershed? So most of you are aware of the political boundaries, districts, states, countries, etc. the water doesn't follow these political boundaries. So, for example, Kaveri Basin is shared between multiple states. Krishna River is shared between multiple states. Ganga River is shared between multiple states. So, when you look at these watershed, it's not just water. It's actually watershed is an imaginary boundary from the inlet to the outlet of a river. And if you look at that watershed, we have this forest, we have this buildings, you have these urbanized areas, you have these grasslands, you have this all kind of roads, transportation systems, and all these are contributing into the watersheds. And when you look at this rainfall which is coming down into this watershed, some of them are being converted to overland flow, some of them are reaching the groundwater, some of them are going into the river, etc. And how do I manage or how do I develop? So when you are looking at infrastructure development, in addition to the water footprint, water scarcity aspect, you have this deforestation, which is resulting in sedimentation, oil and chemical spills, which causes toxins entering into the water. Road construction. When road construction is happening, sedimentation happens and these sediments enter into the streams. Agriculture. Several nutrients like nitrite, phosphide, sedimentation will enter into the water. Stormwater runoff, especially water coming from the urban systems, toxins, nutrients, pathogens, etc. Coastal development, like different sedimentation particles. Septic system failures, different pathogens. Some of you might have heard about E. coli or coliform contamination. All these contaminants enter into the water system. So when you are looking at sustainable infrastructure development, you are not just looking at one particular aspect of availability, demand, and then you are looking at the quality aspect. And that's why you need to have a holistic understanding. You need to have multiple stakeholders from different sectors looking at water security as the central portion while designing sustainable infrastructure. Because water security to me, sometimes it could be water quantity aspect. To you, it could be water quality aspect. For you, someone else, it could be water and health aspect as well. So a typical watershed, you have a valley floor where you have streams coming down, joining into a bigger stream, and then it comes down as a aquifer, you have water, etc. This runoff from rainwater, most normal, can contribute significant amount of pollution. So we need to identify the different kind of pollution. How are these pollutants transported? Some of you might have heard about multiple stories of endosulfan contamination or some contamination which is contaminants which is moving through water. And there are sectors, there are sections where which is focused on contaminant transport bonding as well. How to reduce or eliminate these pollution sources is another component of it. So watershed management, all activities which occurring within a watershed will somehow affect the watershed, natural resources, and water quality. We need to design new lands. We need to look at runoff from already developed areas, agricultural activities, household activities, septic systems, water diversion, etc. And when you look at this figure, you can see that acid rain recharge, pesticides and fertilizers, manure, water table levels, municipal water supply plan, hazardous waste dump site, urban runoff, landfill sites, automobile, gas station seepage, nitrogen compounds, etc. So there's a need to look at water infrastructure with respect to all these components as well. How do we design these watersheds plan management? We need to build partnership because again, this is not a decision made by one person. It need to have participation from the residents in that particular region, landowners in that particular region. Even though they are not residents, they might be somewhere else. Federal, state, municipal, government officials, any associations, watershed association, environmental groups, civic groups. Some of you might be part of different clubs, green clubs, or maybe environmental clubs, local businesses leaders, industrial leaders, agricultural users. What are the agricultural users? They might be leasing that region, they might be owning those regions. Developers who are planning to build a shopping mall over there. Teachers, recreational users, they might be visiting maybe once in a year or so. So, what are the requirements? So, we need to build partnerships. We need to have a meeting, a stakeholder meeting, where you have all the inputs from these participants before designing sustainable infrastructure. We need to determine the priorities for action. What are the infrastructure improvements? Municipal stormwater system. How do I maintain it? Improve it? Replace some of this treatment system? What are the connections to municipal stormwater system? How can we reduce paved areas, impervious cover, etc.? Zoning, subdivision regulation can be revised to address reducing load coverage or impervious cover, reducing roadway widths, encouraging cluster and low impact development, limiting land disturbances, especially when you are looking at clearing of land or looking at development setback from the sources. We need to determine what is the priority of action in our region, looking at various aspects: water footprint, water scarcity, water demands, water quality, and several other relevant topics based on discussion with multiple stakeholders, and you need to prioritize our action, infrastructure improvements. And once you determine the priorities of action, we need to identify, okay, now that I have identified this is my priority. How can I manage for greenways? How can I look at vegetation buffers along water bodies and wetland areas? How can I establish sewer avoidance area to limit development? How can I increase inspection and maintain existing septic system? Identifying resource, wildlife habitat restoration priority, increasing and promoting public access and greenways, and identifying areas where it is appropriate to do so as well. Moreover, you need to look at practices. So once you have a system in place, you need to have the homeowners, landowners to follow certain regulations. Maybe they have to reduce the lawn areas, they have to reduce the fertilizers they use, chemicals being used. Maybe we have to recommend washing cars over lawns instead of driveways. So rains water can drain into lawn and not drain into storm drains. Non-structural flood protection efforts. There is flood damages, especially after Kerala. Today in Kerala flood, there are significant damages. How can we manage our infrastructure? Improving waste management, improving pollution prevention, improve recycling efforts at municipal facilities and businesses within watersheds. Conduct educational programs. Outreach and educational efforts can include periodic information meetings, stream walk assessments, organized storm drain sensing project, watershed cleanup days, information kiosk, videos, newsletters. So different awareness programs can be conducted to help watershed management as well. Ensuring implementation and follow-up as well. Establishing milestones and committees to monitor it, data gathering through different restoration process, assisting landowners for implementing improvement, integrating recommendations. So it's not just planning and management. Once you implement it, you need to look at the compliance. Is it following the governmental regulations? And is it being currently enforced? If yes, we need to monitor it. Okay, now that you have set the rules, monitor it and collect feedback. And if you want, you can reevaluate it, assess it, and redo the same procedure. And if you look at the concerns watershed condition across the United States, green colors are functioning properly, yellow colors are functioning at risk, and red colors are impaired function. And you can see that some of these red colors, especially in the western part of the United States, where you have significant water issues, water availability issues, droughts, floods, and you can see that there are impairments over here. Yellow color zones are also over in the Appalachian region, especially in the eastern part of the United States. And you can see that these are some places which are affected by significant human interventions. How can you contribute to the sustainable infrastructure? Some of you might be expert at hydraulic modeling, remote sensing, photo analysis, road and trail planning, sediment source inventories, sediment transport analysis, stormwater management plan, stream channel surveys, stream restoration planning and design, watershed management plan, watershed restoration cost or estimation, construction management. So all these aspects are important. So when you talk about sustainable infrastructure for water security, you are not just looking at one particular aspect, you are looking at a variety of options. And some of you might be expert in one or the other, which, and you, along with a group of researchers who are experts in multiple aspects, contribute to this water security aspect and sustainable infrastructure aspects. Let me talk you to one example. In Maryland, United States, Tinkers Creek stream restoration. Before restoration, there were several human intervention, deforestation, and then construction was commenced on November 2019 and completed in under 2 years up to 2021. After restoration and after the post-construction, you can see that there is a clear waterway, and this water is actually very clean, or the quality is actually improved. So there are evidences where you can improve infrastructure, you can manage watershed. So what was the stream restoration activities? It included Payne's Branch, Meeting House Branch, Tinkers Creek, and water tributaries. These streams were historically straightened to accommodate sewer main infrastructure. Many streams were eroded previously, so there was trying to achieve a meandering state because you are looking at erosion and then water engrossing into the floodplain and then taking away some of the sand, increasing in impervious surfaces. To reach a stable geometry, stable streams ate away at public land, private property. It threatened infrastructure, delivered large volume of pollutant to the southern creeks, especially Chesapeake Bay watershed in the eastern part of the United States. What was the restoration approach? Realigning the stream, stabilizing the stream bed with wood, stone structures, etc. Interlocked fibrous root system of wood door structures. General water quality uplift by the project has improved aquatic habitat too, because you see more aquatic habitat. That's actually a biological indicator too. When you see significant improvement in aquatic habitat, you can say that, oh, my water body is really good because that's why this aquatic habitat is surviving over here. Headwater tributaries, especially at the upstream end, they were rehabilitated. Several trees, several shrubs were planted to increase water quality and habitat uh, benefits, etc. Another example from Florida, Reedy Creek. The stream was essentially broken before the construction. After construction, you can see that there is an improvement, although it is still ongoing. So you can see when you see a stream, when you see the water condition of your locality, you can see that there are concerns, and you need to understand what are the infrastructure issues, what are the concerns, what is the reason why this is happening, and then you design, then you collect opinions from different stakeholders, and then you start designing. Another Buckley branch of Reedy Creek, Florida, again, before construction and after construction, especially with the sustainable infrastructure practices. Upper Hood branch, before construction and after construction, you can see that the stone laid paths actually improved on the water quality aspect. If you look at Delaware before, after, you can see that there are watershed stewardship. So there are several success stories which you can use to establish that, yes, I can use my infrastructure capabilities. Maybe I'm a hydrologic modeler. Maybe I'm a stream restoration effort modeler. Maybe I'm an infrastructure design modeler. Maybe I know how to manage these construction related activities. Maybe I know how to straighten these rivers, these water quality issues. And if I compile all these inputs from multiple stakeholders, multiple experts, multiple researchers, I might be able to manage the water resources in my locality. And you need to familiarize yourself with your watershed. Comprehensive watershed plans should first identify the characteristics of watershed. When you talk about a disaster like a flood or a drought or even water scarcity concern, you are looking at watershed design. It's important to establish a baseline of overall nature and the quality of the watershed in order to plan properly for the improvement of resources in the watershed and to actually measure those improvements. It might need to map the watershed boundaries. Some of you might be familiarized with ArcGIS or any geographic information system tools, which you can delineate and map the watershed boundaries to identify what are the resources, what are the natural drainage, man-made drainage, what is my land use pattern, agriculture, urban, industrial, domestic, soil type, alluvial, or any other different types of soil, what are the areas of erosion? What are the structures, stream banks, construction sites, quality of water resources, point sources, any pollution sources, any industrial discharge pipes? Are there any industrial sewage coming into the stream? What are the known point sources like municipal stormwater system, failing septic system? So you need to identify those places. Once you identify it, you can delineate watershed. ArcGIS can delineate. ArcGIS is one of the tools. You can delineate using different methods called pour point. You based on a digital elevation model when you have the elevation data set. If you set pour point as your stream gauge or outlet point, you can say that to that outlet point, what are the places where water is contributing? And when you look at digital elevation model, just by looking at elevation, you can accumulate flow water. It's called flow accumulation. And there are several algorithms used to calculate the flow direction. So for example, when you have 78 as the 78 meter as the elevation, 72 meter as the elevation over here, 67 and 74, water will flow from 78 to 67, the most dominant slope. So if it's going in the diagonal, bottom diagonal direction, you assign a value of 2. So you can see that this is the direction, so you can assign 2. The same way you can assign all the grid cells and you can say that, okay, this is my direction of flow. At this particular grid cell, that's my direction. And using that, I can identify, okay, now I know the water direction. Now I know the construction related activities. Now I know the water quality aspect. I can design for this. And when you look at global water resource issues, climate change is another concern, increasing floods, increasing droughts. When I say increasing floods, the flood frequency, uh, the flood magnitude is increasing while drought frequency is increasing. Natural disasters, hurricanes, other disasters, war and conflict, significant water issues with respect to war, water pollution and health issues. Nowadays, people are talking about cancer, Parkinson's disease, cardiovascular disease generated from environmental contaminants in water, international water conflict. For example, Arctic Ocean. Arctic Ocean is claimed by some countries as their own, or some countries as an international water body. International lack of infrastructure. Some of the places, especially in the African subcontinent, there is no infrastructure available to access the water. Migration crisis, refugee crisis, and then you have water security and environmental injustice, where available water is not uniformly distributed across people of different races, gender, etc. When you look at climate change, human activity, natural variability, you can see that reddish color zones, which are the bad zones, especially over the time from 2002 to 2016, you can see reduced water supplies, impaired water quality, and affect the water infrastructure as well. So we need to look into these concerns while we design sustainable infrastructure aspect as well. If we look at for the United States, without climate change, this is the projected change in water withdrawal. Maybe by 2050 to 2060, there could be an increase in 10 to 25%. But with the climate change, it is projected to around 25 to 60, or some places more than 50%. That's very high value. Natural disasters, floods, landslides, storms, waterborne disease outbreaks, several waterborne malaria, and other aspects, loss of life, damage to water and sanitation infrastructure, degradation of environment. So water disasters, whether it's drought or flood, they are getting more intense as the planet is warming up. There are several studies. 2 years ago, one of the studies published, it reported that both droughts and floods are increasing. So there is climate change. Drought frequency is increasing, meaning there are more number of droughts per year. Flood magnitude is increasing. When there is flood, the magnitude of flood, there is significant amount of water coming through flood compared to the previous floods. War and conflict. And if you look at the 2000 to 2009 against 2010 to 2019, it almost tripled, more than tripled for Asian continent. For Africa, more than doubled. For all the places, more or less similar or increased in value. So as water becomes a weapon of war, we must focus on cooperation and peace. Water pollution and health issues. More than 80% of sewage generated by human activities discharged in rivers and oceans. Environmental pollution, more than 50 diseases. So imagine the magnitude of water. Why water is an important concern when you are designing and sustaining infrastructure. 80% of diseases, 50% child deaths worldwide are related to poor water quality. Modeling shows that biochemical oxygen demand or biological oxygen, BOD, is projected to decrease or increase in some places compared to the other places as well. Water quality South America, Southeast Asia, Sub-Saharan Africa would get substantially worse. International water conflict. It's reported that 920 million people, almost 1 billion people, could face conflict over the world's rivers by 2050. And that's from the UN Water Conference. So conflict at local and regional scale, demand greater than supply, dispute in control over access and allocation of water, weak water management institutions, etc. Lack of infrastructure. Many governments lack the infrastructure to properly invest in water resources. In the United States, when you look at large systems or when you look at the millions of people, private wells, race and income disparities, etc. Around 1.6 billion people across the world lack access to the water infrastructure. Migration and refugee crisis, informal settlements. People will cross the nearest border to flee conflict, which often leaves them in an area that faces similar climate events or similarly stressed resources. Food demand replaced by refugee migration is reported to influence water use in water stressed countries. That is a paper published in 2023 as well. So when you look at this water footprint, it's displacement, migration, refugee displacement is increasing. Environmental injustice aspect. North Carolina North Carolina polychlorinated biphenyl protest of 1982 is considered as the first public environmental justice movement because there was a company and their toxins were released into the local water supply. There were protests from different people. The protest was a failure because the government still, the industry still continued to do that. And several residents, especially of low income or minority communities, were affected by this toxic waste and industrial activities. If you Natural Resource Defense Council called the protest as the first major milestone. Governor Jim Hunt later promised the residents in 1991 that this will be addressed, but that was too late for us. Another success story is from the Standing Rock Sioux tribe for the Dakota Access Pipeline, where you have this 19 million gallon of hazardous fracked oil from which was supposed to transport from North Dakota to Illinois, passing through the indigenous lands. This would have endangered wildlife habitat, but the campaign attracted supporters from all walks of life. The protest was successful, and it was able to make sure that people can make changes. To summarize, I talked about water scarcity, how to quantify sustainable water use and water scarcity in India using water footprint aspect, water demand, availability, and then I talked about clean water sanitation as the important aspect, ensuring availability and sustainable management of water and sanitation for all. We talked about spatial distribution of water stress, per capita available water, especially the northern part of India being affected. When there's a reservoir, how it is influencing the stress. Reservoirs can carry over water from high flow period to low flow period, reducing the water stress as well. Talked about clean water and sanitation being one of the major goal which addresses these water-related disasters. Water use and scarcity, water resources management, ecosystem, sanitation, hygiene, etc. Lastly, but not the least, I would like to acknowledge different organizations: Idaho Water Resource Research Institute, Institute of Modeling Collaboration and Innovation, University of Idaho, University of Melbourne, National Taiwan University, TKM College of Engineering, where I did my undergraduate, IIT Madras, where I did my master's, University of Melbourne, where I did my PhD, Northern Arizona University, Cancer Data Register of Idaho, United States Geological Survey, University of Idaho, where I did my postdoctoral fellowship, and Radford University, where I am currently working as an assistant professor. And finally, thank you all for listening to me. If you have any questions, feel free to ask me now, put that in chat box, or reach out to me, or you can also scan me at this level. Thank you.
Thank you, sir. Now it's a time for queries. If you have any queries, you can please unmute your mic or you can type in the chat box.
Sir. Hello, sir. Am I audible?
Yes, you are audible.
Sir, can you please explain me the role of rainwater harvesting in sustainability?
Sure. Thank you. Thank you for asking that question. So you are looking at rainwater harvest sustainability. So when you are looking at rainwater harvesting, you are actually carrying over water from a rainy season or a high flow season to a time when you don't have enough water from rain or from other sources. So you are basically carrying over water from high flow period to a low flow period, which means that your availability during the low flow period improves. When your availability improves, your demand can be met. Your demands can be met. Sorry, irrigation, industrial, domestic, environmental, etc. For most often, domestic demands can be met. And when your domestic demands are being met, you are not facing water scarcity issue. So when you are looking at rainwater harvesting, that's a very important topic because that's an aspect which can be used to alleviate the impact of water scarcity or water stress, especially during summer season or especially during the time after the monsoon season. Because rainwater harvesting, when you look at month by month or those variations can be significantly reduced using rainwater harvesting. And we have evidences, especially from reservoirs, that zero point 0.1 to 0.2 billion people are facing less water stress from reservoirs. So rainwater harvesting is more or less like a miniature version at the domestic water demand level. Thank you for asking that question.
So myself, Dr. Suel from Srinagar, sir, JNK, sir. I have a
Hi.
particular, so I have a simple question. As you're the expert from the field, can you please tell us what are the common mistakes, or just to give a gist of that we are adapting when we are constructing rainwater harvesting structures in the hilly terrains, and does this impact the rechargeability and the aquifer conditions in this case, or just a brief now, what are the common mistakes such that we can avoid those in the hilly terrain? That's a few, just two to three broader perspective that should keep in mind.
That's a that's a very important question, and the short answer, the answer to that question is really complicated, because you are when you are constructing a rainwater harvesting tank, especially when you whichever construction you are making, you are encroaching into the environmental cycle. And again, especially in the hilly terrain, when your water cycle is being disrupted due to this rainwater harvesting tank, depending on the size of the rainwater harvesting tank. If it's at the domestic level, yes, it may not impact the resources as much as we imagine. But if it's at the larger level, yes, that is actually influencing the recharge levels too. So there is a need to look into the natural cycle aspect as well. So that's one of the reason why we researchers, water resource researchers, focus on environmental flow, how much water is required to meet the demands of environment. So whatever construction, whatever aspects you are making, you need to understand that the ecological flows are being met. And that's again an ethical question, because people might be wondering, like, okay, we don't have enough water to meet ecology, we need to meet our own demand. So if I leave that aside, the ecological demands are should be met, and that if that is also a priority, then if you construct in water harvesting tanks, especially at the domestic level, um, they may not affect, influence the cycle. And the volume, the size, also the location, especially if there is a location where significant aquatic life is being located. Not just rainwater harvesting tank. If you are looking at reservoirs usually store water at the upstream end, and downstream end is actually being influenced. You can see, if you visit several dams, you can see that downstream end is more or less influenced by this reservoirs, and significant impact on aquatic habitat too. And most often these questions are addressed through our priorities. What is our priority, and how can we manage these resources through allocating water through the tail end, through allocating water from our reservoir or from our rainwater harvesting tank through the environment. So that should be our priority, and that's short answer. That's the overarching objective. And to be specific to your question, so we look at rainwater harvesting tank volume, we look at the location specifics, we also look at the cultural and also the aquatic life or the environmental demands in that particular region. I hope I answered your question to an extent.
Yeah, thank you so much, sir. Actually, this question has arose in my mind because keeping in mind the terrain of this JNK, recently we have expanded the national highway that is connecting the Jammu and Kashmir.
Uh-huh.
Recently, in the past 1 year, the national highway has been expanded. Now it has been changed to 4 lane. So there is one thing: the runoff that accumulates during the winter or the rainy season, the slopes have been disturbed. So whenever there is a rain, the runoff exceeds the limit, and there is again a landslide. So as a precautionary measures, the experts have suggested for constructing of the recharge pits and the rainwater harvesting structures on the upstream. So that's why this question has arose.
Yep,
So
yep.
so much. Hopefully, I was able to take a glimpse of this. Thank you so much for your expertise in the field, sir.
Thank you, thank you. Thanks a lot for your insights. I totally understand the question, specific, especially with respect to landslides, um, and the short answer is researchers are trying to understand these problems, and there is no perfect solution for it, but there is only optimal solution. There are only best solutions as of now, which you want to balance the development and you also want to balance the environment. And unfortunately, development and environmental improvements are on the two sides of the same plate. Thank you.
Thank you so much, sir.
Sir, some questions on the chat box.
Sure, I will take a look at it. Um, what indicators are used to measure watershed management success? That's a great question. There are multiple indicators, one of them being the water quality aspect. Most often, some of the areas are concerned with coliform contamination. Some of the areas are concerned with grazing of cows or maybe other localities, other contaminating the water. Water quality aspect is the major concern. The second component is the availability component, is the water availability mimicking the past, the historical flow. So you can look at flow health. There are indicators called flow health, and there are indicators of hydrologic alteration where you have a bunch of variety of indicators which also focus on this. And water availability, water quality, and then any human health related aspect. For example, are there any carcinogenic contaminants entering into the streams, which means that even though many other contaminants are low, due to this carcinogenic contaminant, which means that there is cancer causing contaminant, the toxicity of water has gone up. So there is a need to look at those component indicators. So there are multitude of indicators available, and some of these are these are some of the indicators.
Thank you, sir.
Thank you. Let's scroll down. Thank you. I hope I answered your question. How can individuals reduce their water footprint in daily life? And what are some effective strategies for promoting water conservation in our community? That's a great question. Again, thank you, Shima, for asking. And thank you, Rindo, for asking the other question too. Reducing water footprint, you did the survey and you know that the places where you reported high values. And reducing water footprint usually starts from understanding how is water footprint calculated, efficiently using the resources, selecting the resources. Can I, when you compare coffee and tea, the water footprint of tea is much lower than coffee. And can I shift to some of the other sources? Or if I use plastic, or if I use other components, what are the water footprint aspects? So our choices, individual level, the choices matter, and the way in which we use water, not just at the water usage on a daily basis, also the product level. What are the products you use on a daily basis? What are the consumption practices? Because they all need water. So that would definitely improve water conservation. Another question from Pooja Surendran. How water stress and population interconnected? Again, a great question. The population is actually one of the major drivers. Increasing in population, you need to understand that the availability is more or less the same. So your available water per person starts declining. So when your available water per person declines, you don't have enough water. So which means that water stress, which is the ratio of water demand to available water, your available water is very low, which means the water stress will go up. So population is one of the biggest driver, and there are researchers who have conducted, is population or climate change driving water scarcity? And there are studies like Kumu et al. In 2016 pointed out that population drives around 4 times higher than climate change. Although there are studies following up which have different magnitudes of observation. Another question from Parvanindu, can water footprint analysis influence choice of materials in manufacturing? That's again a great question. Yes, the short answer is yes. The long answer is it's not just a choice made by a water resource expert. It also needs an expert from a construction management perspective. It also needs an expert from an economic perspective who would be willing to say that, okay, this product, if I use this product, is it going to be efficient in all the other ways? And I would vouch, definitely vouch for water footprint being one of the component, being the choice of materials in manufacturing. Are there any more questions? Or I don't know whether I have missed any questions from the chat.
All questions we answered, sir.
Thank you. Thanks a lot for confirming that. Yeah.
A heartfelt thank you to Dr. Naveen Joseph, sir, for sharing the expertise and insights on water scarcity and drought vulnerability, etc. The session was really informative and filled with the real-time case studies also. And the session was very interactive with some exercises also. Thank you so much, sir. Thank you so much.
Thanks a lot for inviting me again. I really appreciate it. Feel free to reach out to me if you have any questions. Thank you again.
Okay, sir. Thank you.
Thank you.
The feedback link is shared through the chat box and through the WhatsApp group. All must fill this feedback. As we wrap up today's sessions, I would like to express my sincere gratitude to all the participants for their active engagement and enthusiasm. Your presence has made this FTP truly special. We look forward this cooperation for the upcoming sessions also. Thank you all.